everyone. I hope you are having a good morning, afternoon, evening, whatever time it may be where you are. Uh, and also to all of ye Americans, I hope you're having a good beginning to your Thanksgiving week. Uh, I will stream at some time on Thanksgiving. I'm not sure exactly what time, but I have tended to do that in the past, and I will also do that this year. I will stream at least a few hours on Thanksgiving, in addition to my usual streams on Friday and Sunday this upcoming week. And I think Tristan is also going to stream at his usual time as well. And yes, Selena is quite happy to see we have a big grid with arrows. Provided that a 9x9 grid is big, then this is indeed a big grid with arrows. So we get to start today with the Xendari puzzle. I don't think we have any announcements other than a reminder that we have an ongoing setting challenge, which is posted over on the Discord. So if you aren't familiar with the rules or you need a reminder or whatever of what the setting challenge is looking for, you can go over and have a look at that pinned in the Discord. As I mentioned last time, I posted a between-line adventure puzzle. If you would like, not an adventure puzzle in the copyrighted sense of Rank's adventure puzzles, but a between-line 10-line puzzle over on LMD called Alarm. If you've not yet looked at it, I at least quite enjoyed it and quite liked the craziness of the break-in. At least the way I conceptualized it. As has been the case for a number of my puzzles this year, I think I found something I really liked, and then I think a lot of people will sort of see it by brute forcing something rather than by seeing the cool thing there. People such as MicroStudy, for example, may have outed themselves in chat, but I do like what is there, and I think there is neat stuff to find. It's possible that there could be a more stripped down version that makes it more there. And yes, as Casey says, please do like the stream if you have not yet done so. It is greatly appreciated because the YouTube algorithm is bizarre in what things it likes, but it likes comments and it likes likes on streams. So if you could click the thumbs up button, it does greatly help. Let's see. Selena is still working on September puzzles. I don't think using the partial solution check feature to cheat, just I think MicroStudy just meant using a gross look ahead to resolve something in this particular instance. All right. So I'll never forget there was a video that Mark did like fairly early in my my CTC watching career, where it was like a bunch of thermos that went one way or the other, but it was ambiguous whether it went one way or the other. And Mark just picked a direction and filled it in, and then filled in the whole grid and was like, well, it's not that way. And then just did it the other way. Let's see. Okay, so today's puzzle we're going to start with is this chaos construction by Xendari. We don't do a lot of chaos constructions around here, but if you want Zeta to do your chaos construction, putting double arrows in it is often a good way to get me to be on board with doing a chaos construction. So here it is. And so we always start with people who support the stream financially at the windmill level or above. They get to look through the list of upcoming puzzles, and they get to vote for which puzzle they'd most like to see. So today, that puzzle that received the most votes was this one. The people who voted for it are the following supporters, for whom I am incredibly grateful. Naverio, Nordy, Luda, Josh, Xendari, Russ, Math Pesto, and David. Thank you all. Thank you so much. David has an incredibly high hit rate. I think David has voted for almost every puzzle that we have ever ended up doing. So if you want your puzzle done on stream, get David to vote for it. That is a winning technique that you can employ. All right. So what are the rules for this puzzle? So we have 1 through 9 in every row and column and region. The regions are orthogonally connected groups of 9 cells, but they have not been given to us, with the exception of the fact that these have been told to be in different regions. And so these are double arrows, so they're not between lines in particular. So the sum of these 5 digits is equal to the sum of these 2 digits. This digit is equal to the sum of these 2 digits, and so on. That is how double arrows work. And every cell on a line is in the same region. So, for example, these are all in the same region. I'll go ahead and mark. And the 2 attached circles must be in a different region to each other. So one of these could be in the yellow region, but they're not both in the yellow region. And if they're not both in any region. And we did a 6x6 the other day with this rule set. So we have that. And so I don't know if we have a recommended bet tree. Tristan has not put one in the grid, so I'm going to just pick there, and we'll see if it works out that way. So Nicholas has made the first observation I was going to make, which is that these 4 are the same color and it's not yellow. And if you've not done chaos constructions before, you might at first say, but that's 9 cells. It's totally okay if this is yellow. But the problem is then these 3 cells need to find a 9-cell region, and they can't because they're sort of isolated. So actually this has to be a different color. We can go ahead and make that green. Now, these digits are 5 digits that are all in the same region. So that tells me that their sum is at least 15, because remember, digits can't repeat within regions. So the minimum sum of these is 15. And if I need to make these 2 circles sum to at least 15, they need to be 6, 7, 8, or 9. But that's already interesting when it comes to this double arrow, because this number is bigger than that number. Because this digit is the sum of those 2. And so that can't possibly be a 9. That means that can't possibly be a 6. And this can only possibly be a 1, 2, or 3. This is giving me flashbacks of a double arrow puzzle I just did by Tallcat. We've got this string of things. So we've got all of that going on. Okay, so a few people in chat have noticed a couple things. One is these can't be an 8-9 pair anymore. Because if these were an 8-9 pair, this cell would have no value, because as soon as this is an 8, that would be a 9. So in fact, it's not possible that these sum to 17. Could be 7-9 with an 8, or 6-9 with a 7 or an 8. But that means in particular, these can only actually sum to 15 or 16, which means that they come from those digits and automatically contain a 1, 2, 3, and a 4. And having spelled that out, it makes it really clear that Jay Dyer's point is true, which is that this circle is not yellow, because the 1, 2, 3, and 4 of yellow have already been used. A region could have more than 2 circles, couldn't it, Acid Helm? If there's a reason why a region can't have more than 2 circles, I don't know what it is. Okay, so next question. Could these cells be yellow? And so I think the answer is no, because if these were yellow, keeping in mind that that yellow 1, 2, 3, and 4 are gone, that would be the 5. The yellow 6 would be gone. These would sum to a minimum of 15 plus 5. That would be 20. That's not going to work. So these can't, in fact, be yellow either. And so we get some border coming in there for yellow. And now, bearing in mind that these can't both be yellow, if this isn't yellow, we're broken. So this is yellow, in fact, and now this can't be yellow by the rules, because the rules are 2 circles can't be the same color, but now this can only be green. And so now yellow has to escape out here, and again, by the rules, this cell can't be yellow, so yellow has to escape out here, and we can create some additional stuff. Oops. And we know this is not 1, 2, 3, or 4, so this is 5, 6, 7, 8, or 9, which is getting us very close to having a quadruple living in this column, which is very interesting, of course. These can't be green now because green already has 7 cells. So this triple, whatever color it is, it's not yellow or green. I'm going to make it orange. Just for sanity. That's a good spot. Okay, several people in chat are saying this. This digit needs to appear in yellow. Yellow only has 1 more cell. Therefore, if I make this cell yellow, in that universe, this digit just can't go anywhere in yellow because none of these digits can be the 7, 8, 9, and none of those can either. So that's not the last yellow cell. This is the last yellow cell. Which is very nice. And it is a 7, 8, or 9, which now has made this cell orange. Very nicely. Which has made this cell not orange because of rules about circles and Fight Club or whatever. Now, there's no way that orange doesn't take this line now. Because if orange doesn't take this line, now orange is at most 5 cells in size. So orange always takes that. And now as soon as orange has taken this, now this can't be anything but orange, or it would be a 1-cell, 9-cell region. And we don't want any 1-cell, 9-cell regions. So therefore, that's not orange. Oh, and we know that's not orange. Orange only gets 1 more cell, because that is 8. So these cells are not orange. And so therefore, the last orange is there, I believe, just by diligent border management, if you like. Okay, this is 1, 2, 3, 4, 5, 6, 7 cells. Interesting. Your sudoku will have a 1-cell, 9-cell region. That will be interesting to see. Okay, this digit is the sum of these two. I had not noticed this 1-cell double arrow. Anytime you're doing a double arrow puzzle, you should always sort of mentally scan for 1-cell double arrows, because 1-cell double arrows are the most useful. 3, 1. So the sum here is, so I don't know if this is worth filling in, but the sum here is a minimum of 8 for these 3 cells. That's a maximum of 3. So therefore, this is a minimum of 5. I'm at least going to fill in. I say that exactly as Nicholas also does the same math. But this is on the 1-cell double arrow. So it is worth filling in, Zeta. It is worth filling in, because now this can't be a 9. And now this can only be 1, 2, 3, or 4. And this can only be 6, 7, 8, or 9. That seems worth noting, and gets me a sort of small-ish 1, 2, 3, 4 over here. That 1, 2, 3, 4 I know goes there in yellow for whatever it is worth. Let's see. row 3, column 4 line has a max of 4 for its remaining digits. Oh, okay. So the point now is, this is Jay Dyer's point. These sum to a max of 11, and therefore these sum to a max of 6. And therefore they can't be larger than 5. But in particular, that means they can't be larger than 4. And so now these 2 digits both go up there. But now Jay Dyer's point about this region is this region now has a whole bunch of digits left, and all but one of them is high. So I've got 3 of my 4, 1, 2, 3, 4s. I've got the 5. So can I put 3, 6, 7, 8, 9s onto this line? And the answer is no, because 6, 7, 8 is 21, and I can't possibly make these 2 circles sum to 21. So the last 1, 2, 3, 4 is here. So these are definitely from 6, 7, 8, 9. As Jay Dyer says, then something about 6, 7, 8, 9. And now I still know there's 2 6, 7, 8, 9s in here. So these sum to at least 13 plus 1 is 14. So that means this digit always has to be at least 5. But it's, of course, can't be 5. So this is also a 6, 7, 8, 9 for what it's worth. Let's see. Okay. Sort of slowly piecing this together. I feel like I could probably do some min-max work in here if I really want to. Like, for example, I definitely can't put both the 8 and the 9 in here. Is there any way I could put the 9 on this line? If I made this 9 plus 6 plus 1, 9 plus 6 plus 1 is 16. I could make these 8 and 8. That would be okay. So I think I can just barely sneak the 9 onto this line as it currently stands. I'm mentally sort of coloring this and thinking about whether this cell has to join those, and I'm not sure. I've got this over here as a new color. Of course, these are a new color. So I've got a bunch of things that do have to be new colors. I keep periodically thinking about that these 2 lines have to go in row 1 somewhere. So they have to go like over there somewhere. Let's see. Yeah, okay. So I agree with Nicholas. This cell can't be 6. Because if this cell is 6, the minimum of this line is 7, 8, 1, which is 16, which isn't going to work. So this is never a 6. If this is a 6, now I put at least 7, 8 there. That seems okay. 7, 8, 1. But then, yeah, I can make those add up in a couple different ways. I could ask myself, I suppose, is it really possible there's a 4 on this line? Because 4 plus 6 plus 7 is 17. Which I think is okay, unfortunately, because I could still make these 8, 9 or something like that. And green is currently in need of 2 cells for whatever that is worth. It is worth pointing out that these 4 digits, someone in chat pointed this out, these 4 digits are these 4 digits, just because those 4 digits can't go anywhere else in column 1. So I at least know that these are at most 6. For whatever that is worth. Let's see, Math Pesto says this can't be 1, because if that were 1, it would make these at least 2, 3, 5, which would be 10, and that can't be 9 for some reason. Oh, it can't be 9 because of that, right? Okay, so this can't be 1 because it would force this total up too much, is Math Pesto's point. And as soon as that can't be 1, this can't be 8. And as soon as that can't be 8, this can't be 7. Because of the fact that these two need to sum to at least 15. Oh, right. And as Sayori points out, we already knew these 2 digits were the same. I just forgot about it. So yeah, so that 8, 9 goes there again. That all felt good, but I don't know that it did a gosh darn thing, as they say. Still need 2 more things. This can't be 7 anymore. That's a good point, because 6 plus 2 is more than 7. So I think that makes it a little easier to see. We've got an 8, 9 pair here. So this is not 8 or 9. Hey, Logan. I hope you're doing well. If this is 3... Carl points out we get the following. This is like the weird case checky, but not in a bad way thing that happened with Tall Cat's puzzle. Because like if this is a 3 and a 6, then this is a 9, except this being a 6 means that's also a 9. This is like almost verbatim the step out of Tall Cat's puzzle that we did the other day. So this can't actually be a 3. This is a 2. And so we get our 2 dance. We have not had Zach do a 2 dance in a while. Woohoo! 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 Thank you, Zach. Thank you. Much appreciated. Alrighty. So these are not 2. That's not a 2. And so now I should think about this, because now these actually sum to a minimum of 9. And so if these sum to a minimum of 9, that means this can't be a 5 or a 6 anymore. It can actually only be a 7 or an 8. If that can only be a 7 or an 8, then this can't be a 6 or a 7, and this can't be a 3 or a 4. Oops, I don't know what I did, but it wasn't the right thing. There we go. So we get that pattern now. So we have created some more things. What if there is a 4 here? Yeah, there could be a 4 here. Yeah, I guess there's a 3 or a 4. There's always a 1 in one of these 2 cells, I suppose now is important. Because if these were 3, 4, 7, that would sum to too many. Ooh, David has gifted 5 memberships. Let's see who gets them. Laura, Michael, Paul Fly, Emily, and Thomas have all received a membership from the month from David. Thank you so much for your generosity, David. Let's get you a donation dance. Boop 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 doop boop 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 doop boop 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 doop boop boop boop. Woohoo! Boop doop doop boop doop doop. Woohoo! Boop doop doop boop doop doop. Woohoo! Thank you so much, David, and welcome to all the new members. Enjoy your Zach emotes that you can now spam in chat. Thank you so much, David. It means a lot. So I think I was halfway through arguing that there really needed to be a 1 here. Because if there's not, these sum to 3, 4, 5, which is 12, and I can't make the 2 circles sum to 12. Okay, so my 1 pencil mark was justified. I just wanted to make sure I didn't forget it. So, I mean, smallest of small deductions. Therefore, this cell isn't a 1 because one of these two is definitely a 1. But now the sum of these has gone up because remember, there's 2, 6, 7, 8, 9s there. And now there's not a 1 or a 2. So the minimum sum of these is now 6 plus 7 plus 3. And so 6 plus 7 plus 3 is 16. So therefore, this can't be a 6 anymore, at the very least. So we've got that. Now, I guess before I was trying to argue, could there really be a 9 on this line? And I didn't get anywhere, but maybe now I can actually. Because if this were a 9, it would now sum to a minimum of 9 plus 6 plus 3. And 9 plus 6 plus 3 is 18. So there's no 9 here. There's definitely a 9 over there. In fact, that worked so well. What if there was an 8 on this line? 8 plus 6 plus 3 is 17. So if there's an 8 on this line, there has to be a 9 there and an 8 there. And there has to be a 3 here and everything. That all works out well. Okay. So several people in chat are looking at this line and saying, and I haven't looked at this yet, but I see a bunch of people in chat saying it, so we'll figure it out together, that if this line sums to 16, it breaks, because that would require this be a 7 and a 9. And that doesn't work because of the weird 2 thing here. Because if this is a 7, that is a 9. And if this is a 6, that's an 8. So, in fact, this line always sums to 15, which means there's never a 6 in there. I can get rid of my corner marks. That is a smart observation from chat. So these are 1, 2, 3, 4, 5. That's not a 5. It is a 6 or a 7. None of these are 6 anymore because they're the same as those cells, remember? Okay. Let's see. It was pointed out before. I didn't note it at the time because I wasn't sure if it was useful. But these can no longer be a 9-9 pair. So the sum of this line now is at most 17. And at least 16, right? Because it's at least 3, 6, 7. So this line can only now sum to 16 or 17. If the line sums to 16, these have to be a 7-9 pair because they can't be an 8-8 pair. That would have to be the 7, and that would have to be the 9, because I would need a 6, 7, 3 on the line. And that, can I not get away with an 8 on the line, Pekrintala? It looks to me like I could sneakily get away with an 8 on the line, just barely, but I am not yet sure. Hey, Thomas, I hope you're doing well. Let's see. I would buy I can't not have a 6 on the line. Because if I don't have a 6 on the line, then the minimum of the line would be 7, 8, 3, which is too many. So this definitely isn't 6. I 100% believe that. Okay, so the point, okay, I understand. Okay, so if there's an 8 on the line, then it sums to 17. But then that makes these an 8-9 pair, and that puts 5 8 9s in these two rows, and I can only have 4 8 9s in these two rows. So yeah, so I can't have 8 here. I agree. So I actually need both 6 and 7 on this line. Okay, I agree with that assessment, which means that one's definitely a 6 7 because it's that one by Ketchup. And so these aren't 7 anymore. So I can get rid of the corner marked 9s. Yeah, that was clever. The way that this would sort of work out to be that. The way it would put sort of an extra 8 in there, I like that a lot. That is definitely a step I would put in a puzzle. And so these are from 3 4 6 7. Because I know there's a 3 4 over here. Is there something weird, like if this is a 7, it's going to break everything in the world in some way? I think that's exactly what happens. I think if this is a 7, it's going to break, because if this is a 7, it makes these a 1 3, which makes this arrow small, which makes this arrow... Oh, no, never mind. Sorry, this being a 7 and seeing that doesn't do anything. Never mind. Let's see. Oh, wow. Math Pesto doing some Sudoku, noticing we have a 3, 4, 6, 7, 8, 9 quintuple. So these are 1, 2, 3, 4, which is very cool. Zamina asking where 6 and 7 go in row 3. Do I know that these two aren't 6, 7? Because I see those are 2 spots for 6, 7. Oh, sorry, this was not a quintuple. Was it? No, this was a quintuple. Oh, it was a quintuple, but it was a quintuple that involved a 3 and a 4. What did I do? So it's 1, 2, 5. What did I do? 1, 2, 5's not enough. Oh, it's because it's not a quintuple. That's why. There's only 1, 3, 4. Sorry. In my brain, this was 5 numbers, but this isn't 5 numbers. This is 6 numbers. But the point is the 6 and 7 are definitely in it. And so this was not a quintuple. In my brain, I just miscounted. So these are just from 1, 2, 3, 4, 5. Because there's a 6, 7 in here for sure. So there's no 6, 7s over here. Okay. Okay. So Carl is suggesting that I X this, which is very useful because that 6, 7 pair sees row 3, column 5. And so this can't possibly be a 7 anymore because one of these is definitely 7. And so whichever one is 7, this can't be 7. So that's always an 8 and a 9 and a 1. So no 1 there. So that's a 1 by our previous corner marking. Oh, and in fact, we can solve for X now because, well, we can solve for this cell, not the X, because 1 plus 5 plus 4 is 2 plus 8. So no 4 there, no 1 there, no 9 there, no 4, no 1, just to update the corner marks a little bit. Okay, this row is running out of digits rapidly. The other 6, 7 now has to go over here somewhere, interestingly enough. If I mark that this isn't a 4, it's being pointed out. Now I actually have a quintuple rather than a zeta miscounted quintuple. So none of these are 3. And so now I know the sum of these cells is the point. So the sum of these cells now is 16. And so we said if it was 16, it could never be 8 plus 8. So it has to be 9 plus 7, like that, which makes that a 6, makes that a 6, makes that a 7, makes that a 9, makes that an 8. Makes these a 3, 7 pair, makes that an 8. makes that an 8. So we've got all of that filled in. I'm sure that has other consequences, but that was a whole flurry of activity there. I'm noticing that 8 in column 3 only has 2 spots it can go now somehow. Oh, I like Nikolai's suggestion of marking this row, because now this cell has to be an 8. If this cell is not an 8, these would sum to 7. And so therefore that is an 8. And this is now summing to either 11, which it can't because it would make that a 4, or 12, which would make that a 5, making that a 3 and a 2, making that a 3, making this a right in 6. None of these can be 2 or 3 anymore. Can't be 4, can't be 5. This can't be green because green has an 8 per Sayori. We've got sorted other stuff I'm sure that we can be doing. Okay, where are my 8s now? So now I need an 8 in row 2. My 8 in row 2 can only go one of these 2 places. And then I guess I've got another 8 down there. Yeah, whatever this is, I can go ahead and give it the color of red. Red can't take that cell, at least. People are saying row 2, column 6 is green. Ah, right. Because green could take this cell, but green needs 2 more cells. And green could never take this cell and that cell. So green either takes this cell or it takes this cell, but even if it does take this cell, it still takes this cell. I always enjoy that argument whenever it comes up for whatever reason. So that is red. By the way, I am told by Simon that this red and green look distinct, even if you have issues with distinguishing red and green. But if that's not the case, please let me know. I try and be mindful of coloring, but I'm told that these are differently saturated or something, but let me know if that's not the case. I try and make sure everyone can see the different colors. So one of these 2 is green. These are a new cup. Is there any chance these are red? I think that's probably unlikely, but I don't know that I really want to prove it. Let's see. Okay. That's a good spot from Martin. Red already has an 8, so it certainly can't take this 8, which means it's not allowed to take either of those, which means that it in fact takes all of these, and now it's nearly done. So can mark off that. This is how many cells? 1, 2, 3, 4, 5, 6, 7. This is 7 cells, so it's certainly not taking that one. Over there. Okay. So if these were a 1, 2, 4, 5 quadruple, that would sum to 12, which would make this a 4, which means that doesn't work. So these are not a 1, 2, 4, 5 quadruple. There's a 3 or a 6 in these cells. I don't know what I'm going to do with that, but there's definitely a 3 or a 6 in these cells. Why did I make that calculation? Who knows? No one could say. Let's see. I guess I should maybe count cells up here or something and try and argue something about some sort of cloistering happening over down here. Potentially. I'm not sure. Maybe there's still too much wiggle room to actually make that argument work. If this circle isn't green, that means I need to fit 2 regions up here that aren't green. Is that a problem? I think they could just squiggle down, couldn't they? Or do I have to make a really heinous argument about it? I think I could make a heinous argument that the other region would get cut off here before getting to 9 cells, but I don't want to unless I absolutely have to. Yeah, what's the maximum this could sum to? Be 6543? 6543. Oh, that would be 18. Okay, so that's too many. 8 is placed in row 2 has been called. 8 in row 2 is in one of these 2 cells. I agree. Oh, and it's not in the one with a given 8. Okay, good. I buy that. Thank you, Josh. So my remaining 8s, I've got 2 remaining 8s, and they are there and there. Dangerous. I will mark it, though, just so I don't have to look at it anymore. Okay. Let's see. Can I say anything like I need a 1 on this line? I really don't think so. This kind of wants to be a red 6, but I think this circle also wants to be red, which is making life more complicated. I mean, I know things like this circle's at least 2, but I don't know what to do with it. Let's see. I might as well now give these a color, I guess. So I think I now have to actually count these cells. So that is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. That's 13 cells. 3 times 4 plus 1, if you prefer. One of which is green. So there is some other color in here. Like these can't all be the things. Oh, and as Garion points out, these 2 8s are different colors. So one of them is purple, presumably, and one of them is not purple. If that's purple, it looks weird, but I don't think it's a problem immediately. Seeing it with the 2 8s was way better than counting. I mean, I think we legitimately don't know what color this is, do we? I don't think so. It could still be red. Let's see. This could unfortunately still just be 1. Now, do I know there has to be a 1 along this line? Because 2 and 3 are gone. So if there's no 1 here, these sum to at least 4, 5, 6, which annoyingly only sums to 15, which would still just make this a 7. So even if there's no 1 here, there's still liberty. So I can't just place that 1 there like I kind of want to do. There's this 1, 4, 5 triple here that Nicholas is pointing out, which we could maybe do something with. So Nicholas's point is greens 1, 4, 5 are in row 1. So these cells are not possibly 1, 4, 5. So if I sort of mark all of the, oops, not like that. If I mark all of these, I know they're not 1, 4, or 5. And so maybe there's a really weird naked single over here. Not quite, but it's not nothing. Unfortunately, that one already couldn't be 1 or 4. I suppose I could do the same with these cells more transparently. 2, 3, 6, 7, 9. That one's not 6. That one's not 7 or 9. I mean, there's no way I have both a 7 and a 9 here. Because this cell is, I guess maybe I should note this cell is at most 6. That cell being at most 6, it's at most 6, by the way, just by Sudoku, it sees 7, 8, 9. That now actually means the sum of this line has to be pretty small. In particular, it's at most 11. And so if it's at most 11, and none of these digits can be as low as 1, there's no 9 on it. Okay, so Nicholas's point is going to get us there, I think. It's going to get us a lot, because of the fact that ruling 1 off of this by noting that the 1 in green was in row 1 is going to be huge, because now we have a lot of pressure. And even a 7, keep in mind there's no repeated digits because these are all in the same region. Why did my purple go away? I don't know why my purple went away. Who knows? But these are... Actually, these are a minimum of 2, 3, 6, which just is 11. Which means that is a 6. Which means that's a 6. And these are a 2, 3 pair, so that's not a 2. Oh, there was a rainbowing incident, I see. Sorry, I just try and rainbow things because I know it makes... It makes Selena very happy when things are rainbowed. Let's see. And so now this is green because it's not purple, because purple has a 6. Very, very good spotting, Martin. So we've got all of that. So now, yeah, these now sum to 14. So who on earth knows what happens? I know there's a 2 or a 3 down here just because these 2 3s are down here. And there's a 7 or a 9 here. Carl doing the smart math. There can't be a 9 here because 1 plus 2 plus 3 plus 9 is apparently more than 14, even though it doesn't sound that way in my head, but it is apparently true. So there's no 9 down here, which means that's not a 9 either, because if it was a 9, it would go down here. So that's a 7. And so these sum to a minimum of 9, which means these sum to a maximum of 5. So they have to be 1, 4, right? There's no way to do this otherwise. Because, again, minimum 9 means maximum 5, but the only way to make a maximum of 5 is 1, 4. So that's a 1 and that's a 4. And now that I know that those sum to exactly 5 because of that, now these have to sum to exactly 9, which means there's no 3 there, which means there is a 3 there, which means there's no 3 there. These are now a pair of some sort, consisting of a 5 and a 9, which gets me a 4. No 4 there. I'm going to note there's a Zackwing on 7, so none of these cells are 7. In fact, I'm going to fill all of those in just so that I can mark that they're not 7, because otherwise I'm going to forget that they can't be 7. Well, this one's certainly not a 9, just for the record. Okay. That 2, 7 pair, Carl points out, looks at that cell. So that is now a 9. Okay. Okay, I'm going to fill in that clump of stuff. So I definitely need a 7 or an 8 in these cells, because if I have neither a 7 nor an 8, the total is only 9, and it needs to be more than 9. I could have a 7 and an 8, just to be clear. That would be okay. Actually, I can't do 3... Oh, no, I could do 3, 8, 2 would work. Exactly. Is there just no way to make these add to 12? There's just no way to make these add to 12, so this can't be a 3, at the very least. If this is a 2, these are a 3, 8. If this is a 6, these are a 7, 8. Wait, is there always an 8? I think there's always an 8. If there's no 8, what I'm left with is 3, 6, 7, which could make 9, 10, or 13, none of which work. So there is always an 8, in fact. Narrowly dodging the bet tree. Oops. And so now I have to actually do math. 8 plus 3 would make that a 2. 8 plus 6 would make that a 5, so that doesn't work. So this is 3 or 7. One of these is a 6. Just for the good of all of us or something. Okay. Kind of want to mark these two cells just recreationally. Aha! My claim earlier that these could not be a 1, 2, 4, 5 quadruple pays off. Because if these are a 1, 2, 4, 5 quadruple, this would be a 4, and it can't be. And all 3 of these are from 1, 2, 4, 5. So therefore, this is not a 1, a 2, or a 5. Bam. And you thought it was ridiculous that I noted that before, but I have shown you, I suppose, question mark, question mark, question mark. Okay. So it is also noted that red already has a 9, so in fact, this is exactly a 3. Thank you to Sayori, which has resolved all of that. Also, I think people are encouraging me to do parity on column 2, because I know this has an even total. Even. Oh, no, never mind. Sorry, that's always odd. No 3 there. Okay, so this circle is only 2, 5, or 6. If this were a 2, I would need these to be 1, 2, 4. If this were a 5, I would need these 3 to sum to 10. It'd have to be 1, 4, 5. If this were a 6, I would need these to sum to 11, which I guess would be 2, 4, 5. Okay, all of those are possible. That's sad. So everything is possible, regrettably. Are any of these looking more restricted today than they were before? No, not really. What about that cell? That cell it seems important enough to mark. Okay, this cell can't be a 2 anymore, because if this is a 2, the line sums to way too much, because the line will sum to at least 11, but this can't be as high as 9. So this is always the 9, and that's the 2. So no 9 there, no 2 there. Okay. Okay, people want to do the coloring up here. I got distracted by doing my double arrow Latin square, although in fairness, we've been making a lot of progress with the double arrow Latin square. So so that's one thing. This can only have 2 possibilities based on whether this is a 1 or a 5. Let me do that math first. So those sum to 1114. So this would be 15. That would make that a 7. Or these sum to 19. In which case 45 minus 19 is 26. It'd be 13. That would make this a 5. So this down here, wait. If this is a 5, this is a 5. Right? Double check my math. If this is a 5, these sum to 19, which means the column sum, which means these sum to 26, which means these sum to 13, which means this is a 5. That doesn't work. So that's a 7, and that's a 1 and a 5. Okay. So our math continues. So these are just a 4, 5, 6 business. Okay, so now let's think about the purple. So row 4, column 7, 8, 9 aren't purple. Right. If these are purple, well, I know this isn't purple because purple already has a 3. So let's give this a color. Let's make it blue. Okay. If these are purple, why is that a problem? Actually, wait, this has to be purple, right? Oh, no, purple could just be that stuff up there. I know chat did this a while ago, so I'm going back to look at... going back to read when chat was doing all the geometry stuff. 4, column 7, 4, column 8, row 3, column 9, traps purple. I'm not understanding people's point yet about this. I agree purple needs a 4. So purple can't stay up here. So purple needs to take these cells. I thought I read in chat that these weren't purple, so I was trying to understand why they can't be purple, but it's easier than that. These have to be purple because purple needs a 4 and it's not getting one anywhere else now that it can't get through that cell. So those are definitely purple. And now this certainly can't be anything but purple, because if it was anything but purple, it would separate purple from purple. And it can't be anything but blue because it needs to get out. Sorry, can't be anything but purple because it would separate purple from purple. Sorry. This can't be anything but purple or it would separate purple from purple. Purple already has an 8, so this 8 has to be blue. These certainly aren't purple anymore, because purple is now at 7 cells. So I can draw a line there, and of course a line there. So purple needs 2 more digits. It can't have a 6, and of course blue needs the 6 to connect anyway, but purple can only take these cells in order to get to 9. Okay. I know chat had that a long time ago, but at least for once I can say I was doing productive things elsewhere in the grid while chat was working on that. Because I feel like we made good progress in lots of sudoku here. That's certainly blue. I agree with that assessment. And so this is not blue, for whatever that is worth. Let's see. So if blue doesn't take this line, blue gets forced to take the second circle. So this is also blue. That's very cool. I like that. So that's 1, 2, 3, 4, 5, 6, 7. That is 7. So this can be, have we officially run out of our standard colors? 1, 2, 3, 4, 5, 6. Yes, we've officially run out of our usual assortment. So let's bring in Hunter to help with things. Sorry, no, this is Simon Sweater, not Hunter. We'll let Simon Sweater help. Okay, so blue does need a 7. What can these cells actually be? Maybe I should just write it all out. Strangely, that can't be a 3 because there's already a 3 in blue. But I don't see a whole lot of restrictions. I can certainly color these if I want. The minimum sum here is more than 6 because there's a 2, 3 above it. And so because the minimum sum is more than 6, this can't be a 1. Because that would not sum to enough. Sure seems likely that this is a 9, but I don't think I know that yet. Okay, so I think there's an interesting thing to be said about 4s in columns 1 and 2. So I think we should say that. So I'll go ahead and plonk down Carnival Cake over here. Carnival Cake has a 4, which means the 4 in this column cannot be Carnival Cake. And wherever the 4 is, whatever the thing is that's not Carnival Cake that takes the 4 is going to need to take this cell. And so that region is going to have to come around like that for sure. So we've got that going on. Let's see. I don't know if that can be a 3, 6. Let's see. I'm being told Carnival Cake has to take this cell because it can't take only those cells because it would have 2 3s. So yes, that's a little tricky to see. But if Carnival Cake doesn't take row 8, column 4, it's this square. But the problem with this square, I suppose more transparently, this square doesn't have a 9 in it. Is an easier way to see the problem, but I saw it the reverse way, which is that it would have 2 3s. But therefore, Carnival Cake definitely takes this cell, which doesn't necessarily mean it takes that cell, because it could take all of those cells and still get there. Let's see. Oh, it can't take that cell, right? It already has a 6, right? Okay, so Carnival Cake can't actually take that circle. So Carnival Cake has to take that cell, which means this is a 3 and this is a 6, meaning that's not a 3 and that's not a 3. So now if this isn't Carnival Cake, we've got a real problem. Oh, wait, no. Sorry. I don't know if this is Carnival Cake or not. I know this isn't Carnival Cake, though. But it's probably red. 2, 3, 4, 5, 6, 7. Yep, could still be red. Bottom blue sky grows, Nicholas points out, because it's currently at most 7 cells. So it needs to take these, which means it in fact takes all of these. Which now forces Carnival Cake to grow here to get a 9, but also forces, because now blue is at 7 cells, this cell now has to be Carnival Cake, so that cell's certainly not the 4. Carnival Cake gets its 9 in one of these 2 cells for sure. This cell's certainly not a 5, because Carnival Cake already has a 5. So we've got that. Okay, this cell is not blue sky, because blue sky already has an 8. Uh, whatever this is, it gets out, but my contention is it could be red. Like that, unless I am missing something. The problem is if it's red. Oh, no, no, no. Sorry. I was going to say something but was wrong. So chat would like me to highlight all of the 8s in the grid. And note that all of the 8s in the grid are these. So one of these remaining 8s has to be carnival cake, and it's certainly not that one. Longtime viewers of the channel will know how much I dislike this deduction. But that does give me that these are carnival cake. And so that gives us this whole thing. So now, that 2 sees over there, which makes that a 1 and makes that a 9. Making that a 4. In fact, these are now both sky blue, because what else are they going to be? And so now that's 1, 2, 3, 4, 5, 6, 7, 8, 9. There we go. So we've got those are 1 and 4. So 4. By the way, this has as chaos constructions go, this has shown a great deal of restraint in terms of what has been anticipated. This is not a 1 or a 5. It is a 2 or a 4. This is a 4 or a 9. These are 1s. This is 1. That's a 9. People would like me to do math on this double arrow because 8 plus 1 plus 5 is 14, and so this needs to be a 5. That will certainly help, which makes that a 1. Makes neither of these 5, makes that not a 1. In fact, makes that a 2, and that is 6. So these aren't 2, and in fact, I need these to sum to 9, so they need to be 4, 5 is the only way that's going to work. There's also a 3 and a 2 up here, a 7 down here. That 4, 5 pair resolves the 1 and the 5 down here, resolves the 6 over there, the 1 there. That is no longer a 2. These aren't 2. That's not 1 or 7. There's a 4, 9 pair in here now, it would appear. And if there's a 4, 9 pair, it had better be the case that these are 5 and 9 and 1, or there's no way we're adding to enough. So my belief that this was going to add to 9 did not bear fruit. It added to much more than that. We've got all of that going on. Let's see, we can sort of fill in these. And so now we have to figure out our coloring. So this is 1, 2, 3, 4, 5, 6, 7. Okay, so there's 2 more cells that are needed here. One of them is a 2. And so this had better be the blue 2, because I don't see any more 2s. In fact, there are no 2s in the grid that are not ascribed to color except this one. So this one had better be blue. Oops, not like that. Sorry. This one had better be blue, not all the 2s. And so the other digit that is needed is a 7. So blue could take either of these, and it would be okay. Oh, the tree could be blue. You're right. The tree could be blue. There's no way this isn't Hunter. Is, I suppose, a good observation to make, because if that's not Hunter, Hunter is capped at 7 cells. So that cell is definitely Hunter. Oh, do I have all my regions is a good question. 1, 2, 3, 4, 5, 6, 7, 8. No, I don't have all my regions. Wait, that doesn't look right. I think I just missed one. Let me just highlight the 8s. Every 8 is in a color, right? Oh no, this 8 isn't in a color, but I only have one uncolored 8, and Hunter doesn't have an 8 yet. Okay, so this is Hunter. Oh, I missed orange. Okay, I was like, there's just not enough room for there to be another region, so I better have all the regions. So now, if this isn't red, the only thing it could plausibly be is Hunter. But if this is Hunter, Hunter would need to be a minimum of that many cells, and that many is 10. So this is not Hunter, it's red. So we can do that. Okay, blue already has a 6, so blue can't take that cell for sure. So we've got all of that. The bet tree can't be blue anymore, because if the bet tree was blue, then this 6 would have no color. So if the bet tree is not blue, the only color left is Hunter. So the bet tree is Hunter. And so that is Hunter. And so now this is Hunter. So Hunter already has a 7, so Hunter can't take that cell. And so therefore blue must take that cell. Blue also... So now Hunter needs to connect. So these are both Hunter. Now Hunter is 1, 2, 3, 4, 5, 6, 7, 8, 9 cells. So now Hunter is done. And so this cell needs a color and only blue is left. So it must be blue. And so we can fill in the 7 and the 3 and the 2 and the 3. And the bet tree is a 2. So congratulations to all the 2 bettors out there. May all your betting tree wishes come true. Oh, sorry. Yeah, this was Simon's sweater all along. Sorry, I was misnaming Simon's sweater as Hunter. Poor Hunter. That was a very good puzzle. The usual sort of grindy end part to chaos constructions, but not as bad as most chaos constructions. Like this was fairly reasonable. Like only the last 10 minutes was a slog maybe of the puzzle, which, you know, for a 70-minute puzzle is not bad. So very, very nice puzzle. And I loved sort of the way the break-in sort of chips in was really great. Sort of like a little bit at a time was sweet. Yeah, the opening especially, but yeah, even sort of going beyond sort of like the opening and the mid solve were really good. All right, I'm going to take a quick break, and I'll be back in a moment with another puzzle. So see you all shortly. Welcome back, everyone. Oh, I just realized I just asked Tristan for more tea, thinking I'd finished my tea, but I have a whole other mug of tea here. Bonus tea. Uh, so, uh, onward and upward. Every stream or every other stream, somewhere in there, I go and do one of my older puzzles. And I'm on a string of a few puzzles that I didn't publish on LMD because I didn't like them enough to publish them on LMD. So it's interesting to see which puzzles I didn't like enough to publish on LMD. But also amusingly, the other day, Tristan was doing a Zegress puzzle. And it had an arrangement like this around box 5, and I was like, oh, it has the zetamath break-in. And Zegress was like, oh, you had this break-in in a puzzle? Which puzzle? And I just said, yes, because I have innumerable puzzles with this exact this exact arrangement around box 5 in some form or another. So this is yet another puzzle with that break-in. And hey, Karen, did you end up streaming yesterday? I didn't get a ping notification, but maybe I missed it. But I know Karen was planning to stream yesterday. All right, so what are our rules here? So we have Renban lines. So apparently, I described this as the digits on them form a run, which who knows what I was, what diminished capacity I was in when I wrote that. But anyway, the digits here are a string of consecutive digits, but in any order. So a run, if you will, from cards. You did somewhat. I really liked somewhat. I might do more with somewhat at some point. All right. So cells separated by a white dot are consecutive. So if you like, a white dot is like a degenerate Renban, something like that. Black dots mean there's a ratio of 2 to 1, so something like 4 to 8. And then we have the eye sees all. Within the caged region, all possible white and black dots are given. Outside of that region, including on the border, dots may or may not be given. Okay. So this is a sort of weak negative constraint, if you want. So this is me sort of messing around with negative constraint puzzles. Anyone who sets much has probably experimented a bit with what happens when you play with negative constraints. And the interesting thing that happens if you play with negative constraints is that they suck. And the reason why they suck is because they lead to some very cool deductions, but then you get priced into putting clues places that you don't want to put clues. And so you end up sort of getting forced to things, and then those clues that you're forced to put, even though you didn't want to, then break your logic that you had earlier that was lovely. And so basically it just degenerates into nonsense. Now, one thing I will say is that Philomeno puzzles don't have this problem. So Miami, for example, Miami is a negative constraint puzzle I set where not a single clue is in the grid by accident. But here, that was definitely an issue. So the reason for the box being here that has the negative constraint is to minimize the amount of excess stuff that sort of extra clues that sort of appeared. So sort of the clues outside of here are intentional, and there would be tons of them if I just made the entire grid anti-Kropke. And you can even just see just how few clues it takes just having this here to make this sort of grid unique when you have the sort of negative constraint. Now, I will say at some point, Sam Kappelman Lines was talking about this, and people were talking about how, like, oh, there's this anti-Kropke puzzle with only one clue, and isn't that amazing? And Sam said, it's not a grid with only one clue. It's actually a grid with a clue between every single pair of cells. Just because it's a negative constraint doesn't mean it's not there. And so, in fact, yes, that is quite true. Is that sort of you're actually giving tons of extra clues by having a negative constraint, which is then, of course, why everything breaks horribly. All right, all of that warm up aside, I'm going to throw a bet tree up there and get going. So the zeta break-in is that if you look at a cell like this, you can ask where it goes in box 5, given that it cannot possibly be consecutive, or it can't possibly repeat on the Renban. You would not have a run if you had 2 greens in it. And so the green definitely goes up here. And meanwhile, you have a similar thing here where there is a yellow over here, and the yellow likewise can't repeat within its run, so the yellow goes over here. And so that means that these are 2 Renban that share 2 digits in common. Namely, the digits they share in common are yellow and green. And then the other 2 digits are different. And so yellow and green are consecutive. And so yellow and green are consecutive, and then the other 2 digits that are on here that aren't yellow or green are also consecutive. And so in particular, the first deduction that we can make is that green has to be in the middle to play footsie with the other digits, or it won't work. And likewise, on this Renban, the digits that aren't green and yellow are consecutive, and so yellow has to go in the middle to play footsie with the others. And so we have here that yellow is now a black dot digit, excitingly. And then we have these things are 2 consecutive pairs. So whatever this is, I'll just make those, maybe purple is a poor choice. I'll make those blue and make these orange. And so the thing that I notice here now is that if I look at row 5, blue and orange can't go both here or both here. So actually both of these are blue-orange pairs over here. So notice that as well. So I know I don't always consistently use this, but here I actually mean this is 1 blue and 1 orange, and this is 1 blue and 1 orange. Now, what digits don't appear on these Renban at all? These 3 digits don't appear on these Renban at all. And so one way to think about this is that this Renban, this is really sort of like 1 length 6 Renban with 2 repeats. And so a length 6 Renban will always have 4, 5, 6 on it. And so that means that these digits come from 1, 2, 3, 7, 8, 9. And so one thing I cannot possibly do is I cannot have 7, 8, 9 here in the middle. If I have 7, 8, 9 in the middle, the problem is the 8 is consecutive with all of these digits. And so there'd be nowhere to put it. And so if this is not 7, 8, 9, that means I need a 1 in here. And it would work just as badly if I made these 1, 2, 3, because 2 is consecutive with everything. And so I need a 9 in here. But if I have a 1, if 1 is in here and 9 is in here, that means that 3 and 7 aren't. So that is to say, as soon as there's no 1 on a length 3 Renban, there has to be, on a length 6 Renban, there has to be a 7. And as soon as there's no 9, there has to be a 3. So there are 3 and 7 here. And so the 2 or 8 cannot possibly go here, is several people in chat's point, because keep in mind, this is a 1, a 9, and a singular 2 or 8. And that can't be the 2 or 8 because that 2 or 8 is consecutive with 1 or 9, and so it would be next to it. So there's no 2, 8 there. That is a 1, 9 for sure. So we've got all of that. Let's see. So now what do I do? I'm sort of inclined to like write out all of my digits in order and then figure this out because one of these two digits is consecutive with green. One of these two digits is consecutive with green, maybe. One of these 4 digits is consecutive with green at least. But I don't know if I quite want to do the thing I sometimes do where I write out my whole number line in colors at the bottom and then resolve it later. So Garion suggests that I think about what yellow and green are, because yellow and green are the shared digits. So if yellow and green are the bottom digits, yellow and green can't be the bottom digits. Yellow and green are the middle, and they're the middle of one of these two things. They're either the middle of 2, 3, 4, 5, 6, 7, because remember, these are a length 6 Renban in total. So one of the possibilities is that it is 2, 3, 4, 5, 6, 7. The other is that it is 3, 4, 5, 6, 7, 8. And so if you look at it, yellow and green are either 4, 5 or 5, 6. And one of them is definitely 5. And it's not the one that's on a black dot. And so our surprise first digit is this one. So that has to be the 5. And so 5 has magically become green again through the Zeta magic of the channel. And let us get a 5 dance. Ba-boop-ba-doo. Woo. Ba-doop-ba-doo. Wah. Ba-doop-ba-doo. Wah. Ba-doop-ba-doop-ba-doop-ba-doop-ba-doop-ba-doop. Wah. Thank you, Zach. Thank you. Amazing. So that's also a 5. This is certainly a 4 or a 6 by our previous observations. So this is a 4 or a 6. Now, right. So yeah. So one of these has the other 4, 6 on it, and it's not that one. So the other 4, 6 is orange, if you want. Because, yeah, I need to put the other 4, 6 in the box somewhere. So 4 and 6 both show up down here. Which means that 3 doesn't show up down here, because 3 connects to both 4 and 6. So there's definitely a 3 up here in blue. And if there's a 3 up here in blue, that means this line needs a 4 that can only go there. So yellow is in fact 4. By anti-black dot nonsense. And so these digits this is either 3, 4, 5, 6, or 2, 3, 4, 5. Those are my only options. 2. Why couldn't 3 be orange? Because yellow was 4 or 6, and 3 can go next to 4 or 6. Sorry, 3 cannot go next to 4 or 6. Right, and so as chat points out, the 6 can't go up here because 6 would be white dotted with 5. So in fact, these are a 2, 3, so there's no 2 down here. Right, yeah, the negative constraint, exactly. So there's a 6 down here, and so it can't be 3, 4, 5, 6 because the 3's up there, so this is 6 and 7 going over here. Okay, and so these digits are from 2, 3, 6, 7. Now, this one's not a 2 or a 3 by magic, so this one's orange. And so this one's blue. Sorry, this one's orange. I did not orange it very well. So this one's blue. This certainly isn't a 7, for the record. It's not a 3 either, actually. Because if it were a 3, that would be a problem. So if it were a 3, the problem is it would put a 6 here, and that row already has a 6. This one's certainly not a 6, because it's next to a 5. So a 2 here would go with a 1. And a 6 here would go with a 3. So I know this digit's always 1 or 3 for whatever it is worth. Right. This is blue. Blue is 6 or 7. And I need to avoid making this a 3-6 for whatever that is worth. Okay. And that's also a good spot from Garion. Now I've got an 8 in here in one of these two spots. The 8 in here rules 9 out of that cell, so that has to, in fact, be a 1. This cell is a 2 or an 8, by the way. Oops. Oops. Oh, these are just... Never mind. Those are just stray marks from my earlier thing. Oh, right, and the 4 already sees that cell, so this can't be an 8 because there would be a black dot. So, in fact, that's a 9 and that's an 8. Like that. I want to go back to these can't be a 3-6, and so if these can't be a 3-6, that's saying these can't be a 2-7, which is just saying this can't be a 7, because if that was a 7, then that would force that to be a 2, which would make those a 3-6. And so now this row actually has the 7 placed. The 7's over there. Funnily enough. So the 7's up here somewhere. For whatever that is worth. Let's see. Let's see. Oh. These are a 2-3 pair now. So this isn't orange anymore. So this is orange. And so it is a 6 with a 3, making that a 2 and a 3. Okay, excellent. Okay, and I think I can probably get rid of the colors at this point. Maybe, possibly. We'll see. Okay, 1 in this box... is in one of 4 spots. 4 in this box, though, is placed. Because 4 can't go next to 2 and it can't go next to 5. So that is, in fact, a 4. Now that means 8 can't go up here because 8 would be next to 7. So the 8, in fact, goes down here. Which now means the 9 can't go down here, so the 9 goes up here. These are, in fact, a 7-9 pair. And these are a 1-8 pair, but we now know the 1 can't go there, so that's an 8 and that's a 1. So now we can fill in these triples, and we can think about how the world works. So these aren't 2 or 9. Okay, 7 doesn't go next to 6 or 8, so that just is a 1 immediately. 3 doesn't go next to 6, so that's an 8 immediately. 3 doesn't go next to 2. 4 doesn't go next to 5 or 2, so that's a 9, 5, 2. And we get all of that filled in immediately. And now that 6, as chat points out, resolves that that's a 2 and that's a 3. And that 8 has resolved that that's not a 7, so that's a 6 and that's a 7. I think this 7-9 is legitimately unresolved. Okay, for the time being, until we do this again. So now we do the most painful marking of all time. And we think about what this dot can really be. So probably this one is the one to start with, because it can't be 2 or 5. Actually, maybe that's not so useful. Oh, the one next to 2 can't be 3 or 4. So this is 5, 6, 7, 8, or 9. So this can't be 1 or 2 or 4 or 6. This can only be 7 or 9, so this has to be even. So it's 6 or 8 for whatever that is worth. This has got a 2 on it for sure. Because it doesn't have a 3 or an 8. So this is from 1, 2, 4 and has a 2. But reminder that we don't get we don't get to apply a negative constraint down here. Let's see. That's not 7 or 9 because it's next to an 8. You can perhaps see why I chose not to publish this puzzle. This is not an 8. That's not an 8. Let's see. That's not a 2. That's not a 7 or a 9 or a 4. That's not a 2. That's not an 8 for what it's worth. That's not an 8. That's not a 2 or a 4. Oops. 2 or 4. This is not a 6. This is not a 1, 3, or 4. This is not a 5 or a 7 or a 3. So we've got all of that. This can't be a 4 either, because 4 would be next to 8. So now this is only 1 or 6. So this is never a 3, or a 4, or a 6, or an 8, or a 9. So this has to be 6 and 5, I believe, making that an 8. So we've got no 8, no 5, no 6, no 5, no 8. This can't be a 7 or a 9 anymore, because it's next to an 8. Let's see. What do I have left to fill in here? We do have our 1, 2, 3, and 4. We've got to do that. Oh, I am told 4 is placed in this row. 4 is either there or there. Let's see. Why can't one of these be 4? It would rule out 2 from the row or something. Oh, right. 4 never goes next to a 2, 8. Right. Whether this is 2 or 8, it can't go there. So that's always the 4. Oh, sorry. So, and I just missed highlighting one of them, but that's always the 4. Okay, that is a good spot. So now that this is next to a 4, it can't be a 3 or a 5. This one can't be a 5 or a 2. And this has now resulted in the placement of 4 within this row, as pointed out by Martin, because that sort of knocked out a 4. So this can't be a 3 anymore, or a 2. So those are a 7-9 pair. That's a 1-7-9 triple, so therefore that is a 2 and that's a 3. So that's not a 2 that we've got over there. Yeah, we certainly have a 7-9 pair here in the column. I don't know if that's useful yet. Nicholas points out this isn't a 6. I agree with that assessment. So 6 in this row is getting awfully congested for whatever that is worth. Okay, so it's being pointed out, this digit, if this were a 6... that's the only even digit that it could be, but this would have to be a 5 or a 5 or a 7, and it can be neither. So this digit's always odd, which means this digit's always even. So it is always 2, 6, or 8. I don't know if it's going to be immediately helpful, but seems worth noting. This can't be 7, agree, because it's next to a 6. It's always 1 or 9. But 9 doesn't have a lot of options, I suppose. Oh, and now the 2 in row 7 is placed. It wasn't last time, but it is now. So that's a 2, making that a 9, that a 7. That's a 5 now. This is not 5 or 7. This is not 5, 7, or 9. We've got, that is now a 3, which makes that an 8, makes that a 1 and a 6. Doing that. This can no longer be 5, funnily enough. That 7-9 pair makes that a 1. Sayori points out. I agree. And I think we are finished our negative constraint puzzle, and so now we get to just look at this and realize that there's lots of options. We can pencil mark this one as well, per Nicholas. So this is always a 4 or a 6. This is always a 7 or a 9. And the only combination that works there is 6 and 7. So this is always a 6 or an 8. So therefore, that is a 7 and a 4. 4, 6. We'll see how long my brain is broken for because of the fact that we just did a negative constraint thing. No 4, no 4. We know there's a 2 over there. Let's see. There's a 1-5 pair here. Very smart. So that is a 2 and a 4. Yeah, so that's a 2 and a 4. Which makes that an 8 and a 6 and an 8 and a 9 and a 6. These aren't 8. It's not 9, not 2 or 8. Oh, 8 isn't next to 3. Fun fact. So that's a 7 and a 5. Making that a 9 and a 7 and a 9 and a 7. And a 3 and a 2 and a 9. A 1 and a 3. 1 and a 5. So we can paint the town with pencil marks, as they say. And so we can fill in an 8 and a 2 and an 8 and a 5 and a 7 and a 2 and a 3 and a 4 and a 3 and a 6 and a 4 and a 9 and a 1 and a 9 and a 5. And our bet tree is a 1. So congratulations to all the 1 bettors out there. May all your betting tree wishes come true. I love the opening here, and so like just sort of like I agree with my past self that this puzzle overall is not very good. The opening is super cool, and I loved sort of like everything through filling in this middle band, and then the rest of it is just pain. It's like there really isn't anything left to do after that other than just like pencil mark it and write every negative constraint elimination. I don't really know what to do about that because like sort of like the break-in was cool, but then the break-in just forces everything. And the original version of this, what I first tried is of course just to have this be a negative crappy puzzle for the whole puzzle. But then when you do that, you get dots here and a black dot there and all of these things. And so there's just dots all over the place. And so that doesn't really work. So at least this made it so at least you had to do the break-in. But then sort of like after the break-in, there really isn't anything, other than sort of negative constraint silliness. Are row 3 and row 7 needed for the break-in? That's maybe not actually. Maybe we don't actually. Maybe we could have just restricted it to be just there. Although that it feels like then the eye isn't seeing very much, but yeah, it could just be maybe just the central band is that. I have experimented in a few different ways with the idea of like take a negative constraint or a weird global constraint and apply it only to one place, like I've done like the central box is anti-night, for example. I think that kind of thing is helpful for sort of like so I think the idea of restricting where it is useful, but then it's hard to make the rest of the puzzle interesting or feel connected if you say like, oh, here's my break-in that uses the negative constraint and then the rest of the puzzle doesn't. I don't know. It's possible that the right thing to do, the thing I'm sort of inclined to try now, is maybe make this the region that the eye sees, because that might be enough to both get you interesting deductions, but also sort of leave enough out that you could sort of still have some interesting spice in these cells, maybe possibly. That would be, if I were to try and fix this today, that's what I would try and fix, is I would try and make it so the eye sees these boxes rather than the boxes that they did. Alrighty. I am going to take a quick break and be back with another puzzle. So see everyone shortly. Welcome back, everyone. I am back here with a James Sinclair puzzle. I love James Sinclair puzzles, but I don't get to do them very often because Tristan also loves James Sinclair puzzles. And so quite often, Tristan will get to them before I do. But here we have snuck a Nabner arrow puzzle into the bucket. Excuse me. So we'll attempt to figure this out. So have normal Sudoku rules, Nabner lines. And so along a Nabner line, you need to have no repeated digits, and the digits need to differ by at least 2. So 2, 7, 9 would be fine. But additionally, a digit at one end of the line is equal to the sum of the other two. So, for example, it could be 2, 7, 9. Just as a hypothetical. And so these are arrows, but we aren't told where the circle goes. And we're going to get a digit right away because you could never possibly put a 1 on one of these lines. The simpler version of the break-in to what was it called again? Antimatter. The puzzle of mine that I think only Ranks and Microstudy have done. I guess Carl has done it because Carl did every puzzle. But that was a puzzle that featured lines that basically were like this and 17 other things. So anyway, that's a 1. And the reason for that is because if I put a 1 here, well, if I put a 1 there, I can't do that. If I put a 1 here and a 6 here, that's going to be a 7, 7. And the point is that 1 plus something is 1 away from it. And so that breaks the Nabner line because these will have a difference of 1. And anywhere I put a 1 on one of these Nabner arrows will do that. Yes, antimatter truly is one of the puzzles of all time. So anyway, so this is a 1 and we get a 1 dance. Boop, boop, doop, woo! Boop, doop, wah! Ba-doop, ba-doop, wee! Ba-doop, 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 whoa! Thank you, Zach. Thank you. So that's going to place a 1 there. And then that's going to place a 1 there. And that's going to place a 2 there, which is going to make this even. And so this is going to be a 4 or 6, and this is going to be a 6 or an 8, because the sum of the line is not 2. That's going to be a 1. That's going to be a 1. Let's see. One of these two is a 1. Oh, except that one's a 1 because of looking at that box. So that's a 1. And that's a 1. And we have many, many 1s into the grid. So these are either... So this line needs a 3. Because if this line doesn't have a 3, the minimum sum would be 4, 6, 10. Because I can't use both 4 and 5s. There's definitely a 3 here. Oh, I didn't place that one. And so there's no 3 on this line. And so now if this line doesn't have a 2, now we're similarly in trouble. So this line definitely has a 2. And now that means that this line, these two, if they are not the arrow, if this isn't the arrow tip, we're going to have problems. I guess I should put circles around the arrow tips. And so we've got that. And now this side is the big side. So this side needs to be the whittle side. So that's going to be a 2, 3. Because I certainly need, basically the thing is I need a 2 or a 3 on every Nabner line or it breaks. Because if I don't use a 2 or a 3, the minimum sum is 10. So similarly, with this one, that needs to be the arrow and this needs to be the whittle one. Oh, and apparently this one needs to be a 3, which means this can only be a 5 or a 6 with an 8 or a 9 there. And so the other 8, 9 is going to be on this line because this is the other 3, 5, 6, 8, 9 is going to be up here. And so ridiculously, this time, people will correct me if I'm wrong, I think we really do have a quintuple. I think this is a 3, 5, 6, 8, 9 quintuple. Hey, Maria, I hope you're doing well. I'm doing well. I'm having a great time with the puzzles so far today. And so these are something and a something. 2, 3, 4, and 7, I believe. How are you doing, Maria? Let's see. Okay, so we've got that 3. So that's a 2 or a 3. The other 2, 3 is certainly on here for what it's worth. The other... No. That doesn't quite do it. This line certainly needs a 3 by the same logic. So this is not a 3. And so because that line needs a 3, this line needs a 2 because it can't have a 3 anywhere on it, but the 2 could go anywhere on the line, I think. This line needs a 3, is being pointed out by Garion, I believe. And so the 3 has to go there. And that's because, again, there's no 2 on it. So this is certainly the arrow circle. And this is a 5 or a 6, as noted. So this is an 8 or a 9. If I don't have a circle, if the circle was here, this would sum to too much. So that's the circle. And there's definitely a 2 along this line because there's not a 3 and the 2 can only go there. This digit can't be a 4, 5, or a 6, weirdly. We can just fill in with the... 1, 2, 3, 4, 6. These are from 7, 8, 9. Well, how do I make this work? Well, only as a 7, 9, and then I have to answer my question whether 7 is 9 plus 2 or 9 is 7 plus 2. I'm not sure I know. I think it's going to be 9 is 7 plus 2. So this is going to be 8 is 5 plus 3, which means this is going to be 6 is 4 plus 2, which means this is going to be 9 is 3 plus 6. I knew the 8 wasn't going to be in the middle. Not that that was ever going to be a huge thing, but I now know that that is that. I can, not that. I can hit in that. So these are going to be 2, 7, 9. The 9's not going to be in the middle. These are going to be something and something. So the circle is certainly not going to be 4 or 5. So it could be 6 is 4 plus 2, or it could be 8 is 5 plus 3. This is certainly never an 8. Could be 8 is 6 plus 2 as well. I think all of those are options. Except I know what this pair is in the row. These apparently are 5, 8. So these being 5, 8 is very helpful in noticing that this is not an 8. Also, that being 3, 5, 8 would have also done that. So this has to be 4, 2. It's the only option. We could have done that in simpler ways. I'll be honest with you. That could have gone better. But we're going to go with it. This line now can't have a 2 at all, so it needs a 3, and the 3 has to go over here. Let's see, that's not a 2 or a 3 anymore. So now this line needs a 2 or a 3, and it can only be a 2, and it has to go there. And in fact, it has to go exactly there. Right. So now this can't be 3, 5, 8, because that would break this cell. So this is 3, 6, 9. In order to make this work with the 9 not there. Looking at that, that's very cool. I like that a lot. I don't know why. That's one of those deductions. I mean, everyone just has their Sudoku deductions they like. That's my my guilty pleasure deduction, we'll say. 3, 4, 5, 6, 7, 8. Like that. So that is a 4, 5, 7, 8 quadruple, meaning that has to be a 3. So that is not a 3. So that means this is a triple. What is left in the column? It's not 4, 5, and it's not 7, 8. 2, 6, and 9 are left in the column. I mean, that one's certainly not a 9. that were a 9, it would go 9, 6, 3. That seems plausible. 6, 2, 4 also seems plausible for what it's worth. So this cell's not 2 or 3. So one of these is 2 or 3. Oh, I should do this the easy way. This one needs a 2 because it's got a 3 looking at it. This one needs a 2 or a 3. That one's not 2 or 3. Why did I think this one couldn't be 3? I thought this one couldn't be 2 or 3, but oh, because there's a 3 looking down at it, right? Okay, this one can't be 2 or 3, so therefore this one needs a 3. Okay, and that 2 looks up and makes that a 7 for what it is worth. This line needs a 2 now because of the 3 pencil mark looking down at it from above. So that's a 2, which sorts out that 9 and that second 7. So we've got that. We've got this now. Okay, so there's certainly no 3. We don't talk about it. There's certainly no 3. There's definitely a 5. And so, because I can't use both a 7 and an 8. And so that's got to be 7, 5. And so the 8 certainly doesn't go in the middle. So the 8 is the circle. So that is the 8 and the 3. And that makes that a 5, which makes that an 8 and a 5, which places that circle over there. We've got 2. Unfortunately, 1 and 3 are already gone in the column, so this could be... Oh, it's not summing to 9, actually. Maybe this is more restricted than I think it is. So the sum can't be 9, because it would be 2 plus 7. So it is 6 with 2 and 4, which means this is just a pair, because it's not 4 or 6. This is just an 8, 9 pair. And these over here, they don't have a 9 in them. They're from 3, 4, 6. That's not a 5. That's not a 7. It's not a 5 or a 7. If this is a 4, this is a 6 either way. How on earth is this a 6 either way? That's weird. Because this is either a 4 here, in which case the sum of the arrow is 6, or this is an 8, in which case the arrow needs a 6. So this is a 6, but I don't know whether it's the head of the arrow or the other way around. That's ridiculous and funny and adorable. 4 and 6 and 3. There might be some sort of clever math reason for that is sort of like more generalizable than me just case checking it to death, but who knows? Okay, so this digit's big, it would seem. So if this digit's an 8 or a 9, this digit's certainly not an 8. It's also certainly not a 4, because I'm not allowed to put a 4 next to a 3. So that's a 5, and that's an 8, which gives me a 7 and a 9 and an 8 and a 7. So 4 there and a 7 there. 8 there, 5 there, 4 there. 8 there, 5 there. Good. Okay, so now let us paint this triple in. So that's a 3, it would seem. So this could be 8, 2, 6, or it could be 7. Oh, it can't be 7. Oh, sorry, it could be 7, 2, 9. Could be 7, 2, 9. Okay. Oh, Paul Fly, on the important things, we didn't put circles in our arrows over there. Which does seem like a pretty big priority. These are 5, 7, 9. That apparently is just a 6 and an 8. So solving for x, that makes that a 5. Makes that a 7. 7 certainly doesn't go with 6, so that's a 2. That's a 9, making that a circle, that a circle. So that is an 8 and a 6, making that our last circle, right? I think, quick circle check. I think we've got all our circles. So that has become a 6, a 9, a 7, a 5. This has become deducible. by I wing. Uh-oh, I forgot one. Throw 3 column. Oh, I am missing one. You're right. Thank you, Maria. Good spot, as well as Martin and Paul Fly. That was almost a mess. 2, 4, 9. 2, 3, 4, 5, 6. And the bet. Oh, sorry. Almost had a premature bet tree incident. And the bet tree is a 7. So congratulations to all the 7 bettors out there. May all your betting tree wishes come true. This is really cute. I liked this a lot. There were several sort of cute sort of deductions from sort of thinking about how this had to work globally. But this is sort of a global deduction puzzle, but a gentle global deduction puzzle. Because sort of deduction 1 is none of the Nabner lines can have 1s on them. And then deduction 2 is every Nabner needs to have a 2 or a 3 on it. And then sort of the whole puzzle was just applying those deductions around the grid. And then we got sort of through all of it. So yeah, I really liked that. That was a very elegant execution. And I appreciate the sort of making an execution of this that was sort of not overly difficult. It was just very smooth, a very cute idea with a cute execution. I liked that a lot. Alrighty, quick break time, and I'll be back in just a moment with another puzzle. All right, welcome back. Having been lulled into a false sense of security with a James Sinclair puzzle, I decided to attempt a Nordy build your own skyscraper puzzle. So we'll see how this goes. Nordy, by the way, one of our turbines, much appreciated for the support. And I always enjoy Nordy puzzles. And we have sort of a number of them sort of percolating that we'll make it through. But here is one of them. So let's start with what a skyscraper clue is. So it was meant to be a 1, 7, 9, 8, 4. 1 wasn't the right one. What digit is missing? 6. There we go. Okay, so a skyscraper clue is this sort of very weird clue where you sort of start from a side and you count the number of digits you see. And the rule is you see a digit if it's the highest digit you've seen so far, and otherwise you don't. So, for example, you see the 2, you see the 3, the 1 you do not see because it's not the highest digit you've seen so far, so it is unseen. The 7 you do see, the 9 you see, and then you see nothing else. Because you're not going to see, once you've seen the 9, you're not going to see anything else. And so again, the way to sort of internalize this, and let me squish the Zeta a little bit so you can see all the rules. Welcome, Rita, by the way. So the way you read an outside clue here is that it's telling you the number of things you see. And so, and again, just to say that sort of as concisely as possible, you see something as long as it's the highest number you've seen so far. So this would be a 4. Okay. Now, notably, it's different if you look at the same string from the other side, because from the other side, I see the 6, but then I don't see the 5 and the 4 because they're not the highest I've seen so far. And then I see the 8 and the 9, and then I don't see anything else. And so from this side, it was a 4, but from this side, it's a 3. Okay. So in a sort of vanilla skyscraper puzzle, if you will, you would just have numbers outside the grid that would give you the skyscraper clue for some of the rows and columns from some of the directions. However, here, more than that is happening because in this puzzle, we have to build all of our own skyscraper clues. And so what we do is we have these standard clue types describing relationships between the skyscraper clues and the things outside. So for example, this cell, its value, together with the skyscraper clue outside in that direction add to 5, whereas together with the skyscraper clue outside in that direction, they add to 10. And then the black dots mean one is double the other. So either this cell is double that cell or the other way around, and this means they're consecutive. I'm assuming there's no negative constraints of any kind, but I don't know that for sure. This is always the sort of thing I find it impossible to skim for. It doesn't say there's a negative constraint in huge letters, so I'm going to guess there are not negative constraints. Okay, so I am going to just drop a bet tree here for you. And I'll start, anytime there's V's in the puzzle, pretty much I start by writing 1, 2, 3, 4 on them. So I feel good about myself. And I'm noticing that because this is 1, 2, 3, or 4, this is 6, 7, 8, or 9. Now, this can't be a 6, actually. Because if this is a 6, then I would need to see 6 digits, but 4, 5, 6, 7, 8, 9, I can only possibly... Oh, what? That would be 6 digits. Never mind. Sorry. It is true, though, this can't possibly be a 1. Sorry, several people in chat have pointed out these can't be 1s because I would need to immediately see the 9 because I always see the 9. So a 1 skyscraper clue can only see the 9, so that's never going to happen. So none of these are 1s. And so none of these, therefore, are 4s. And therefore, this really isn't a 6, but the other way around. So I have that. Does 7-3 work? 7, yeah, it just works. So you're going to need to see, regardless of how this works, you're going to need to see every digit that you can. Okay, so could this possibly be a 9? If this is a 9, so I have to go 1, 2, 3, 4, 5. No. If this was a 9, that would mean I'd have to put all the skyscrapers in order. It would go 1, 2, 3, 4, 5, 6, 7, 8, 9. But in particular, you'd put a 5 on a black dot. And you have to ask yourself, can I put a 5 on a black dot in this puzzle? Because it would go offside the grid. But it would put a 10 outside the grid. And although there's nothing to stop you from having a 10 skyscraper clue sort of innately, it is a rather large problem to have a 10 skyscraper clue, given that there's only 9 skyscrapers you could possibly see. So this is not a 1 and a 9. Which means these are 2 and 3 for sure. Given that. I can do a similar thing over here, but I don't know if it's worth writing out because there's a bajillion possibilities over here. That's a smart spot from Garion. If I put a 6 or higher here, that means this digit's at least 5. But once I'm at least 5, there's only 5 numbers left I can see. 5, 6, 7, 8, 9. So I can't put a 6 or higher in any of these white dot cells. So these are all from 1, 2, 3, 4, 5. And therefore, and likewise, this can't be a 6 either, because if this was a 6, it would make that a 5, but I wouldn't see that either. So again, these are also from 1, 2, 3, 4, 5. And we have the same issue with these being 1s that we had previously, J. Dyer reminds us, because of that. Okay. Okay. So, a lot of people are telling me this is now a 2. That would be huge if it's true. If this is a 3, yeah, I don't quite see that. This is a 1, 2, 3, 4, 5 as well because of that. I will agree with Glob there. Did I mark the X right? Oh, sorry, you're right. 5, 6, 7, 8, 9. Good spot. Yes, I for whatever reason, yes, I did fill this wrong, right? So yeah, so it could be 5, 5. I don't think there's anything to stop it from being 5, 5. If I was making this puzzle, I would make it 5, 5. So, who knows? Okay. So, so I want to go back to a point I saw Jay Dyer make earlier, which is that I can't make any of these 4, 8. Because if I make any of these 4, 8, it's a problem regardless of which order it goes. If it's a 4 there and an 8 there, well, I'm not getting to 4. If it's an 8 here, sorry, it's an 8 here and a 4 here, that's also a problem because I can't get to 8. So these black dots are a little more restricted than they would normally be, which is that they're 1, 2, 3, 6, 4. And again, I don't have 1s here outside the grid because the only way you can have a 1 is to have a 9 immediately after it. That time I actually remembered that you couldn't put a 1 outside the grid. Okay, I agree with that. Paul Fly's pointing out this can't be a 1 because that would do the same thing up there where it would make it a thermo, where it'd have to go 1, 2, 3, 4, 5, 6. But the problem is this can't be a 6. So that's not a 1 and that's not a 9, I can at least say. This can't be 6 because if this was 6, the most I could see on the skyscraper was 5, and that's too few. So that's not a 6 and that's not a 3. 9 is restricted in row 1. I certainly can't put a 9 in any of these cells because I need to put at least, the 9 needs to be at least at the 7th cell. So the 9 is certainly over here. Agree with that from Sayori. Uh, which means this certainly isn't a 1, because if this is a 1, that would be a 2, and this would need to be a 9, and it can't be. So we've got that. Oh, and the same is true, Nicholas points out, in row 9, actually, because conveniently this is at least 5, so the 9 needs to be at least this far, but then that forces the 9 over into this box over here. Even 2 here is too small, because if this were a 2, I would need to see only the 9, and I could hide the 1 there, but I still can't put a 9 even there, so this can't be a 2 either. Oh, that's not the clue. Sorry. The thing I was arguing couldn't be a 2 is that one. Oh, no, sorry. I was somehow interpreting it simultaneously as both. Can this be a 2? If this were a 2, this would have to be a 3 with a 1, 2 there. Yeah, that's okay. That is fine. Okay, so I agree with J40 that the point here is I need to see every digit that's bigger than this. So if this is a 2, I need to see every digit that's bigger than this. And if this is a 3, I need to see every digit that's bigger than 3. And so J's point is, where's the latest I could see the 5? The latest I could see the 5 is... Am I confident that I couldn't see the 5 here? I'm not confident that I can't see the 5 here, if I'm being honest. So I don't 100% believe J40's argument. Oh, right. I have to see all the digits remaining. So the thing is to think about it from that direction rather than from this direction. So yeah, so you have to see the 9, you have to see the 8, etc. So yeah, let's try and say this elegantly. So I need to see every digit larger than this. I need to see this and every digit larger than it. And so in particular, I need to see the 9, the 8, and the 7, which means that the 9, the 8, and the 7 are seen, which means this cell can't possibly be seen because this, in that universe. So this cell is unseen, and so therefore it can't be 3, 4, or 5. So I think therefore this is 2. That's not really... I feel like I didn't argue that very well at all, but I'll accept it. So that is therefore a 3. No, this is immediately broken. No, isn't it? Isn't this immediate? No, it's not immediately broken. Right, I get to see one more thing, and then I need to see the 9. Okay, yeah, I can hide one more thing. Yeah, so this is a 1 and a digit, and then that has to be a 9, right? No, I could just put an 8 here. Never mind. Sorry, I'm thinking about wrong things. But that too does see that by sudoku. So neither of these are 3. If that one's not 3, that one's not 6. This being a 2 means this needs to be smaller than the 3. So this isn't 4 or 5. And now this is almost assuredly, but not quite assuredly going to be seen. Let's see. This is not going to be 4 or 5 anymore either. So both of these being 2 seems just impossible. If both of these are 2, I'm going to need 2 9s in box 1. Because if both of these are 2, it's saying these 2 are the only digits other than the 9 they see in their column. Oh, right. Sorry, we get a Zach dance. Sorry, the 3 was our Zach dance. Boop boop doop. Woo! Ba-doop ba-doop. Wah! Ba-doop ba-doop. Wee! Ba-doop ba-doop. Wah! Ba-doop 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 ba-doop. Wah! Thank you, Zach. Thank you. Much appreciated. This digit can't be a 2 anymore. So this is definitely a 2, actually. So the thing I was trying to prove was wrong. I don't know why, but somehow it was wrong. So this would better be a 4? Because if this is a 1, I definitely need a 9 after it. And I can't have a 2 and a 1. I think this is broken. This is just broken. I can't make this work, right? We might have to start over. Because I need to make this a 9, right? If I make it not a 9, then I don't think this is possibly ever working, right? Make it a 1, 2. Oh, yeah, I can make this a 1, 2. You're right. I can make this a 1, 2, and then put the 9 there, and that'll be okay. Okay. All right. Okay, I see it. It makes sense. All right. This is for real, not a 2 because of that. Let's see. So yeah, so either these are both lower than 4, or these are both lower than 3. And either way, that claims the 1, 2s in the box. Oh, and it can't be that these are both lower than 4. That option is not possible, because the version where both of these are lower than 4 creates a 1, 2, 3, 4 quintuple in the box. So these are both lower than 3. That is a 9. And now, if this is anything but a 9, the clue breaks. And so now that just is a 2 by definition. So that's a 1 and that's a 2. That 3, 4 looks at that cell, says that's not a 6. Oh, that says that's not a 2 either. So that's not a 4. So this is 2 or 3. Okay, I think that all eventually worked out, maybe, possibly. Oh, sorry, 5, 6, 7, 8. However, this, by this clue, can't be a 6, 7, or 8. Because if this is a 6, 7, or 8, then I have failed to see the 5. And the only digits I'm allowed to not see in this row are the 1 and the 2. So that has to be a 5. Now, I think these are a 1, 6 pair either way, maybe? I don't know. Let's see. But it's okay if, which regardless of what order it is, if it's a 1, 6 pair, I think. I certainly have a 9 down here somewhere. I'm just going to mark for reference. Yeah, right. So this is either a 1 or it's the 6 is the point. And the reason is this. It's either a digit I don't see, in which case it's the 1, or it's the next digit I see, in which case it's the 6. So this is 1, 6, and that does let us do 7, 8, 9 for the rest of the row. So that is a big plus. The fact that both of these skyscrapers are so small is weird. Yeah, this can't possibly be 1. Because if this is 1, then that's a 2, and now I need to make a skyscraper of 2, and I can't because the 9's down here. So this actually is 6 and 3 and 1. This digit has to be less than 6 because I can't see it. So 2, 3, 4, 5 are the only options. This is 1, 2, 4, 8 now. For the record. Oh, why am I thinking it's a 2? Sorry, I'm somehow... Sorry, this is a 3, not a 2. My brain has somehow hardwired that all skyscraper clues are 2s. But not all skyscraper clues have to be 2s. Let's see. Oh, this isn't a 1 anymore, so that's not a 4. This has become a 9 by Sudoku, Garion points out, and that becoming a 9 by Sudoku has removed the option that this is an 8, which removes the option that this is a 2. And even this being a 7 is impossible because this cell's never seen. So that's not a 7, and that's not a 3, actually. So this isn't a 2 either. Let's see. 5, 5 would require me to see the 6, the 7, the 8, and the 9. So 5, 5 doesn't actually work because I would need to see all of 6, 7, 8, and 9. Oh, no, I could do 6, 7, 8. That's fine. Is it the 4 that doesn't work? If this is a 6 with a 4, I need to see 5, 6, 7, 8, and 9. And that doesn't work. Because if this is a 6 with a 4, I need to see 5, 6, 7, 8, and 9 in addition to the 4. And I don't have room to see 5, 6, 7, 8, and 9 before that. Okay, so this is 5, 5. Making that a 4. And making it so that I have to see the 6, the 7, and the 8 in that order. I'm going to try and avoid looking at the Sven telling me that that's not 4, because that's not correct. That's not an 8, at least. That is true. Oh, this is a naked something. This is not 1, 2, 3, 5, 6, 7, 8, or 9. Yep, this is a naked 4. So that is not a 4. Oh, this isn't a 5 either. That's not a 5. This isn't a 5. This is 1, 2, or 3. For what it is worth. Let's see. Being told this can't be a 9 because it would have to go 8, 9. Ah, right. Yes, okay, so yeah, so this can't be a 9 for a sort of cheeky reason, which is that if this is a 9, I have to see this cell, and it would have to be an 8, but this would also be an 8, and so that doesn't work. So the 9 in this column only has 2 places it can go. Oh, sorry. Oh, no, it can't go there, right? It cannot go there. So yeah, so the 9 goes in one of those 2 places. row 3 skyscraper can't see a 6. Ah. So if this is a 6, that's a 3. But then the skyscraper clue would be a 2, because if this is a 6, the 7 and the 8 are hidden, and so you only see the 6 and the 9. So this can't actually be a 6. Let's give you 3. Thank you, Jennifer. Let's see. These are 5, 6, 7, 8 as well. Yeah, if this is a 1, the 9 is way too far away. This is... No, sorry. If this is a 1... No, it's still a problem. If this is a 1, that's a 2, and I would need to see the 9 immediately, and I can't. So this is never a 1. Oh, so this can't be 4 anymore. This is either 2 or 6. Oh, yeah, if this were 3 with a 6, I think that's also a problem, Chad is telling me, because if this is 3 with a 6, I would need to see 6 of the digits from 3 to 9, so I would need to see 6 of the 7 digits from 3 to 9, but I would see neither of these. And so that would be a problem. So this can't actually be 3, 6. This has to be 4, 2. Which means these two digits both have to be less than 4. So these have to be a 1, 3 pair, because I now need to make sure that I see the 9 almost immediately. And so the 9 can only go there, because the 9 there would be too far away. And so now one of these is a 7 for the row, because the 7's not here. So 1, 2, 3, 4, these are from... Oh, and one of these is the 6 for the row as well. So in fact, these are just a 6, 7 pair is what has happened. And that is an 8. And these are an 8 and a something. 2, 3, 4... It's a 5, 8. Is what it is. These digits are 2, 3, 4, 5, 6, 7. It's not a 6 for real. That one's not a 5 for real. That one's not a 7 for real. And so these are 2, 3, 4. I don't think I get any help with that. Immediately. That's very clever. Garian points out that if this is 8-4, it would force this to be 5-0, because 5 can't go with 4 or 6 if this is 8-4. So there's no 8 here anymore, which means that one of these is 2, which means that's not 2 at the very least. This cell is always seen. So the cells seen in the column are these two and the 9. Oh, no, that's not quite a problem. The 2 in column 5 also looks down, that's true. So this is a 1 or a 3. So this is a 2 or a 4. Oh, right. Sorry, I was thinking it was seen over this, but no, if it's a 5, it's not seen. You're right, Garian. I was just looking at it. It's bigger than the 3, 4. But yeah, it would be hidden by the 6. That's correct. Let's see. This is a 1, 2, 3, 4 quadruple in this column. So these digits are not from 1, 2, 3, 4. 5, 6, 7, 8, 9 is what is there. That one's not an 8 because there's an 8 in the box. That one's not a 9 because there's a 9 in the row. This one's not a... Oh, this is just a naked 7, isn't it? It can't be anything else, but it's by the white dot alone. So I think that's a 7 and that's an 8 regardless. Once you notice the quadruple in the column. Okay, so now we see the 6 and the 8, but now it's going to be a 3 regardless of where we put the 9, so it doesn't matter anymore. Let's see. Yeah, this could easily go 2, 1, 9 now. That's fine. This is never a 7. It's never an 8. These are a 5 and a 9 pair. Okay, so these are even now. So this is either 2, 8 or 4, 6. And that one's not 8, so that one's not 2. Just for the record. Let's see. Carl says... Sorry, no. Jay says... Sven is right. This can't be 4. Because we could see 3, 5. But then we couldn't see anything here. And then we can see the 9. But 3, 5, 9 is not 4. So the absolute maximum this skyscraper can be is actually... well, it's not 4. So it is 2. There. So, right. So this can't be a 5 anymore. Whether this is a 1 or a 3, this can't be a 5. Because then I would see 3 skyscrapers. So that's the 9 and that's the 5. Okay. Okay. And so Carl was saying to look at the column 7 skyscraper. So I see both of those. I don't see that one, but I'd better not see this one either. Because if I see this one, then I'm also going to see the 9, and that's too many. And so that means this can't be a 6 or an 8, because if this were a 6, it makes that a 5, which means I'd see those 3. So this is actually just a 4 and a 6. That makes these a 2, 3 pair. Makes these in the row 1, 2, 3, 4, 5, 6, 7, 8. 1, 5, and 8. That one's not an 8, at least. This one's not a 5, if I scan carefully. This one's not a 4 for real. That's not fake. Okay. So we've got all of that. Nine in row 7 needs to go in one of those 2 cells. And so Garion points out, and so because 9 is in one of these 2 cells, this can't possibly be as high as 4. So that's not a 1. It's a 2 or a 3. That 1 looks down and says that's not a 1, Glob Glob points out, which means that's not a 4. So these are a 2, 3 pair. Oh, and in fact, that 2, 3 pair actually looks up there and sees that that's a 4, 3, 2. I said that badly, but there was an actual 2, 3 pair in the column, not involving the external clue over there. So these are a quad of something, something, and something. 1, 2, 3. I suppose I should say these are a quad of something, 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 and something else. 1, 3, 4, 5, I think. None of those are 5. That is a quad within the box. So these are an 8, 9 pair, I believe. And so these are a 2, 3, 4, 5. These are a 6, 7 pair, I believe. So there's no way this is a 2. Because I'm going to see this 2, 3, I'm going to see a 6, 7, and then I'm going to see an 8, 9. So this has got to be a 3, with that being a 2. And so now if this goes 6, 7, I've now already broken the bank. So that's 7, 6. And now if this goes 8, 9, I've broken the bank. So this is 9, 8 in order to make that work. And that 2 has told me that's a 2 always. Makes that a 3 and that a 2. That 3 actually looks down there and says that's a 1 and that's a 4. These aren't 3. These aren't 1 or 4. That's not an 8. It's not a 7. That's not a 2 anymore. If that's not a 2, that can't be a 4. This can't be a 6 anymore because it would need to see every digit up to the 9, and that's certainly not going to happen given that that's a 2, so that's no longer a 6, that's no longer a 3. 2, 1 is also assuredly broken because if this is 2, 1, I would need the 9 right there, and I can't have it anymore. So this is 3, 6. And I need to see the 7 or the 8, but not both in these cells. If it's the 7 goes there. If it's the 8 goes there. That 6 looks up, seeing that 7, that 5, and that 6, and that 1, and that 3, and that 1, and that 8, and that 5. Okay, maybe did that do it? No, I don't think so. Let's see. What is left in this column? We still need a 1, a 2, and a 3, and we've got the 4, the 5, the 6, 7, 8, and the 9. Yep, we've got a 1, 2, 3 left to place. And the 1 is placed, actually. Oh, that's an 8. Right, that did do it. J40 and M Nasty both point out that did do it, not because of something that happened up here, but because it placed an 8 in the box. So now the 8 is unseen, so the 7 has to be seen in order for that to work, and the 7 can only be seen there. Let's fill in this triple. 2, 3, 4, 5, 6, 7, 8, 9. So we've got all of that. Puzzles are good today, Naverio. How are you doing? 1, 2, 3, 4, 5, 6, 7, 8, 9. This isn't a 5 or an 8. Actually, was that? Yeah, it's not a 5 or an 8. This isn't an 8. I'm double checking that Sven is not leading me astray. This is a 2, 3, 9 triple, though. If that's a 2, 3, 9 triple, that means this is just a 5. Or alternatively, 5 is just placed in here by Sudoku. Take your pick, whichever of those sounds better to you. Those aren't 5. One's not a 9. Okay. Alrighty. Row 7, column 8, not a 4, I am being told. Ah, yes, not a 4, because there's a 4 in the row. And ergo, that seems to be a 4 just sudokologically. Okay, I believe that. Okay, so this clue is done now. In fact, I think our only remaining skyscraper that's possible to break might be this one. I think that might be true. So Sayori says this can't be a 3. Because if this is a 3, that's a 2, and that's a 9. Got it. Okay, yeah. So if this is a 3, it makes the clue a 2 because by forcing that to be the 9. So in fact, that's a 2, and that's a 3, which makes that an 8, and that a 9, and that a 2. That a 9, 3, 2. That a none 8. So let's see. So these are, let's see, we still need a 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 4, 6, 7. That one's not a 4. These need to be a 1, 2, 3, 4, 5, 6, 7. Sorry, not 6, not 7, 8, not 9. No 8, and in fact that 7 sees over and says that's not a 7. While we are doing things that are things. That one's not a 4 because there's a 4 above it. let's see. Tristan is working on extracting rat excrement from our kitchen, so he is not presently working on running the bet tree, unfortunately. Hey, Music Cuber. Uh, uh, oh, there's a 3 in row 7. That's good. That is good. I'm also being told that there is a 6 in row 6. Thank you. So that is not an 8. That's not an 8 either. One of these is definitely a 5. I was trying to decide what the most genteel way to express what Tristan was doing was. I decided on that. That's a 6-7 pair, so that's a 5. Oh, and there's a 6 there looking over there, so that's a 7 and that's a 6. One of these is a 7 for sure. These are a pair of something and something. One of them is a 1, and one of them is 8. So that's the 1 and that's the 8. Meaning those are not 1. This is 2 or something or something. Two or 6 is what it is, and it's not a 6. Sorry, it's not a 2, so it is a 6. You got a 7 and a 6, making that a 4 and a 1 and a 4. You got a 7 and a 3 and a 1. Meaning that this is a 3, and our bet tree is a 2. So congratulations to all the 2 bettors out there. May all your betting tree wishes come true. Someday Sudoku Pad will support handling this kind of puzzle better, because I feel like this is a standard enough kind of puzzle that it would be really nice if the Sven scanning worked for it intelligibly. Which is, of course, no shade or slight on the puzzle. The puzzle was delightful, but I fantasize that someday Sudoku Pad will handle a 9x9 grid with some stuff outside, because it would also work nicely with things like cipher puzzles where you've got a key on the other side. This is Chrome, Nordy. So it's not a Chrome Safari thing. It's just that it didn't see the regions correctly is the problem. And I think it would have to be intelligently programmed to understand what the regions are. No, solution check already worked. Solution check worked fine. I wasn't complaining about the solution check. I was only complaining about the scanning being wonky for this particular puzzle. And it seems like the sort of thing where if Sven can handle scanning some of the more complicated things Sven has handled, this seems like something that's probably a low priority but could be handled. And yeah, if something is imported from Sudoku Pad, it's going to break Sven scanning because if it's imported from Penpa. Yes, I agree it's worse that it works sometimes and not others. Although somehow, inexplicably, it turned out that for the outside, every time Sven tried to tell me some conclusion on the outside, it turned out that if I'd just listened to Sven, it would have been correct. Yeah, I probably should have just checked or just turned it off, but I didn't. But yeah, Penpa doesn't include any way to mark what the regions are. So if you're importing something from Penpa, it's never going to support this because Penpa doesn't know, whereas something like F-Puzzles does know what the regions are, and so should in principle be able to be marked perhaps as a collaboration of the Rank's work on improving F-Puzzles and Sven's work on improving Sudoku Pad, letting you mark these are the regions, and this is a none region that I don't care about, would be helpful. And, you know, in a dream world, it would also let you write 2-digit numbers in outside or whatever, but, you know, talking down the road. But if you look at how much Sudoku Pad has improved over the past year, it is quite an astronomical amount. So I think that I think there is a good chance that these things will happen. I just get greedy. Yeah, Mark TechFan's importer is really nice. It does a lot of cool stuff. Yeah, two-digit numbers anywhere, if the setter specifically allows it, would be also nice. You don't want it by default to let you enter two-digit numbers in cells, or it would be a nightmare from a map point of view of entering digits in the grid, because you'd go to enter a 2 and then say, no, I'm going to fill in the 3. But then it would give you a 23, and then you would throw things across the room. Not Zach, of course. You would never throw Zach across the room, but less lovable animals might get thrown across the room. But as long as sort of the puzzle specifically set up to support it, then I think it would make sense so that you could have your 23 ominoes in your Philomeno grids or whatever. Alrighty, I'm going to take a quick break, stretch, and come back with another puzzle. By the way, please do take a moment to like the stream if you have not yet done so. It does help the stream out a lot if you do so, because it helps get people's eyes on it, and then people discover the stream, and then it also helps, weirdly, YouTube doesn't like notifying everyone who's subscribed unless there's enough likes on it, so then some people, even who are subscribed for notifications, don't get them unless you like it or whatever. Anyway, I wish I could not bother you to like the stream, but unfortunately, as a YouTuber, I am obligated to say things about liking and clicking the thumbs up button. So please do that for me while I take a quick stretch, and I'll be right back. All right, welcome back, everyone. Next up, we have this Parity Mirror Mr. Menace puzzle. So we have killer Sudoku rule. So the digits in the cage sum to the total. So these digits sum to 11, these sum to 27. And importantly, you can't repeat digits within cages. So if I make this a 5, I can't also make that a 5. It will make Sven very angry. And we want to make Sven happy so that Sven continues doing all the wonderful work that Sven has been doing. This is not a Sudoku diagonal. This is a parity mirror diagonal. And so each cell has the same parity as the cell reflected across the mirror. So for example, row 2, column 6 reflects to row 6, column 2. If one of these are even, they're both even. And if one of them is odd, they're both odd. Those are the rules. I'm going to place a bet tree here for this. And yeah, there's some Instamath in that these cells sum to 38, and so these cells sum to 7, and so they must be 1, 2, and 4, Sayori points out. So these can't be 1 and 4, because if these are 1 and 4, that would also be 4. So therefore, there's definitely a 2 in here. And if it's 1 and 2, this is a 6. And if it's 2 and 4, this is a 3. So we've got all of that going on sort of instantly. So this has no 1s, 2s, or 4s in it. So this 24 cage... Well, yes, it definitely has a 7 in it because the 7's not going in the 14 cage. It has a 3 in it, and so yeah, it's either 5, 9, or 6, 8, whichever way it works. Yeah, and so these are the same parity regardless, but I don't know what that parity is yet. Okay. It's not true that all the numbers on the line have to be odd, but what is true is that within each box, an odd number of odds need to be on the line. So either everything on the line is odd, or exactly one digit along the line is odd. That 1, 2, 4 seemed super helpful, but I don't know what I am doing with it or with my life just yet. We will figure it out at some point. It means 2 of these cells are even, so that means that 2 of these 3 cells are even. I don't really know what I want to do with that exactly. This doesn't reflect to that, does it? Okay, let me double check. No, that's not right. No. That is what reflects to that. I was looking for like if one of these cages would give me a parity thing. I will note my usual a 12 cage always has a 1 and a 2 in it at the very least. Part of this. Let's see. This 27 cage, it's going to reflect up here for whatever that is worth. Jay Dyer says these are the same parity because these sum to an odd number, I know. So these sum to an even number. And so therefore these, which sum to an even number, these need to sum to an even number, so they're the same parity. Let's make that parity yellow. That's cool, sort of like combination of box math and parity math. And so that means that's yellow by reflection, and row 2, column 4, that's yellow by reflection. is a cool observation. However, the fact that it reflects into the box with no clues worries me that it might not be the intended one. So these all have an even sum, so the total sum of these is odd. But I don't see a lot that I'm able to do with that immediately. Okay, yeah. So Jay Dyer had a more elegant way to see that than I did, which is that these three cells definitely have the same parity sum as these three cells. So therefore, those two have the same parity because they need to complete in the same way. Okay, so as Garion points out, this this reflection, actually, I know that these sum to an odd number, so I know that these sum to an odd number. Therefore, these sum to an even number, and so these are all the same. But I don't know if it's yellow or not. But I could do a dash there to say these are the same. And if those are the same, then these are now the same because of that. Although they don't have to be the same as those. It's just sort of two pairs of that. And so I should reflect that back. That is row 3, column 8, which is row 8 and row 3, column 9. So these two are the same parity as well. Maybe actually yeah, I'm going to get rid of this for the moment. That's true. That's true. This is definitely a same domino. So this is definitely there we go. Okay. This is the same domino because it's a two-cell cage with an even sum. So this is the same domino, which means the sum of all of these is even, which means the sum of this cell is definitely odd. There we go. Okay, so that's row 9, column 4, and so row 4, column 9 is also odd. For whatever that is worth. Hooray! We have a shading, and it's not a 1. So we actually have it down to only 4 candidates. We're practically there, yes. Where did these 3 cells? Oh, those 3 cells reflect to those 3 cells, right? Okay. Yep. So what else can we do? Does this need to have... It needs to have a 1 or a 2 at the very least. But I don't think that's super exciting. It tells me there's a 1 or a 2 up here, but that seems even less exciting. These aren't 1 or 2. So I guess one of these cells is 1 or 2. If this cage has both a 1 and a 2, these two cells are a 1-2 pair. Still doesn't quite sound exciting. Okay. So these two are opposite, right? Because of the fact that these sum to an even number, whereas these sum to an odd number. That tells me that these two are opposites. So whatever parity this is, that is, and it's the opposite of whatever parity. So these two are of opposite parity. Does this immediately do anything? Not that I could quite see. Oh, we can do almost the same thing in box 5, Nicholas points out, which is to note that these cells sum to an odd total, whereas these cells sum to an odd total, and therefore this has the same parity as that, so I can put an O there and an O there. Okay. In fact, they differ by 4. M Nasty did the work. Josh has bet 5 on the bet cell being a 10. We will see how it goes. The circle catch-up isn't a digit. Circle catch-up is a parity, unfortunately. It's either odd or even. Ah, yes. Okay, there we go. So Danzor points out these two have the same parity by parity mirror, and so therefore these two have the same parity. So this is also circle parity. So that's 3 circles in the row already. So this 11 cage can't be all odds anymore. Because if it were all odds... Oh, no, maybe it could even. Sorry. It could still be all odds if those are all the odds in the row. Yeah, never mind. So this row's parity, say where he points out, we know is odd because we know all of that sums to an even number. Row 6, column 6 is circle J, because Danzor pointed out these two are the same parity by parity mirror, so they have an even sum. And so therefore the remaining two in the cage have an even sum as well. So these have an even sum, so these have an odd sum. So I think I believe the claim that the 11 cage takes the last circles. Because if circle is odd... Oh, no, because it could be an odd and 2 evens. But yeah, I don't think knowing that these have an odd sum tells me anything. Oh, I guess it does, because these have an odd sum and these have an odd sum. So therefore, these two have the same parity. So that's always circle, right? Isn't that true? These 3 have an odd sum, these 3 have an odd sum, so therefore these have the same parity. So yeah, so that's a circle. Okay, so now this is a circle X pair, actually. Sorry, let me reflect that. That row 6, column 1 is reflects to row 1, column 6 while we're at it. So now that's 4 circles. So now 11 now the 11 cage definitely is not all odds. But these could be XX, I'm afraid. Right. Okay, right. So J. Dyer has it. So if circle is even, now the 11 cage breaks, because now the 11 cage has an even sum. Because if circle is even, that's all the circles in row 5. Sorry, in row 6. And so these would be odd, odd. And odd plus even does not work. So circle is, in fact, odd. Very good. So we're going to get a digit out of that after I do the important part of the coloring. So so we have that. That is very cool. Okay, and so this is an odd 3-6, and so it's a 3. And we get to do a 3 dance. Boop-a-doop, wah! Ba-doop-a-doop, wah! Ba-doop-a-doop, wah! Ba-doop-a-doop, thank you, Zach. Thank you. Much appreciated. So that makes these, by the way, a 2-4, which makes that a 1. 1 is odd. These are both even, because 2 and 4 happen to both be even. That 2-4 reflects over to row 1, column 7, and row 2, column 7. So it reflects over to those two. These need to be even, because if these aren't even, then they're odd, and that's too many odds in the row. So these are even. And they reflect to row 2, column 6, and row 3, column 6. So those are even. I never reflected this one. Row 3, column 7 reflects to row 7, column 3. I did not reflect that. Good spot. 14 needs another odd. I don't know what we're talking about. The only 14 cage I see is this one, but it's not the one people are talking about. This 14 cage. There we go. Thank you. Yes, there's this 14 cage. It needs another odd. I agree. And so row 4, column 7 corresponds to row 7, column 4. There we go. So there are 2 odds in this 12 cage, because you need 2 odds in the 12 cage. And so therefore these are both even. Yeah, every 12 cage has 2 odds and 2 evens. Today I learned. So these are both odd by the row, because now that's all the evens. So that's odd, and now let's reflect all of that stuff. So this is row 7, column 5, so row 5, column 7. This is row 8, column 4, so this is row 4, column 8. I have given up on trying to intelligently reflect things, because I screw it up every time. So now I have just gone to the... I am just going to manually reflect the coordinates every time I have to do it. Okay, so this is an even and an odd for sure. So this is an even and an odd for sure. And if this is an even and an odd, that's the last odd. So therefore that's even and that's even. Also, as Sayori points out, this is even because, sorry, no, this is odd, actually, sorry, to make this work. And so that's odd, per Danzor's point earlier, that you always need an odd number of odds on a diagonal. So those are both even. So we've got that. That digit and that digit can be ketchuped in the traditional sense of ketchup because of that. These are the same digit because that digit needs to appear in this box and can only appear there now. These two are the same. These two are the same. Not quite so close. Okay. Both 2 and 4 go in the 21 cage by Sudoku, points out Carl. That's very slick. So there's definitely a 2 and definitely a 4. And so this can only be 7 or 9 to go with it. That is true. I guess it's worth marking these are a 6-8 pair. Not a 6-7 pair, probably. 6-8 pair. One of these is a 1 just by Sudoku, because there's got to be a 1 in this cage. And so that 1 now percolates up over to here somewhere. These are both even or both odd. Do I have any feelings about that? Not really. My 20 cage certainly can't be all evens anymore. Oh, I guess that's super true for lots of reasons. Can my 20 cage have no evens? Yes, of course it can. Let's see. Okay, there's a good spot from Paul Fly. This cage can't be all odds because all the odds would sum to 25. So 2 of these are even, and so therefore these are both odd. Beautiful, beautiful setting and beautiful observation there, Paul Fly. Row 1, column 8, and its buddy there. And so now I can get rid of the line. No longer need that. Okay. We've got that. So these can't both be odd because, oh no, crap, they could both be odd. Never mind. I was going to say, because then that would be a 1. And then I got very sad when I realized that I was going to say, because then that would be a 1. It was not a good, good time. Okay, so Martin says these are both odd. Sorry, Martin specifically looking at these because otherwise there are too many evens in box 5. Right. Because if these are both odd, now these both become even, but then by the even number of odds business, sorry, an odd number of odds on the diagonal business, that's also even, and that's 5 evens. Wow, that's slick. Let's see. Is there some natural way to have seen this? Oh, okay. So here's how I should have seen it. I know that these two are the same parity. So therefore I know that these two are the same parity, and therefore these two are opposite parities. Therefore one of them is odd, and therefore there aren't 2 odds left in the column. I was that close to seeing it earlier. If I'd have pushed just one bit more when I saw that this was checkerboarded, then I could have gotten that same same conclusion. Okay, so that's all the evens in this box. So now the rest of those are odd, and all the evens in this box, so the rest of those are odd. And so now that's a 5, because the odds sum to 25. Hey, Franco, how are you doing? It is always great to see you around. Okay. Yeah, so we've got that now. So this 11 cage doesn't have a 5 in it, for whatever it's worth. Does not tell me a whole lot. The 26 cage also doesn't have a 5 in it. Doesn't tell me a lot either. Yes. Poor Josh's 10 bet is no longer possible because the bet tree is odd. Ooh, Nordy gets on Simon today. Is it for the puzzle we just did? Row 9, column 4. By math. Okay, so let's do this. So 27 plus 23 is 50. And so the digits... Oh, right. These sum to 50. And then, so that's 45. Right. So these highlighted cells sum to 45, but these also sum to 45. So therefore, these are catch-upable, is the point. Okay. I now understand. Yeah, huge congratulations to Nordy. Okay. Screaming Ice Cube says row 6, column 4, and row 6, column 7 have a difference of 4, and neither can be 5. Ah, okay, right. So by our earlier box math, which is not how I originally did this, these sum to 45, these sum to 49, therefore this is 4 bigger than this, but the only option, therefore, is 7 bigger than 3. And so these are 2, 6. Oh, hey, Mr. Menace. I hope you're doing well, because they need to add to 8 and be even. So this is 4 or 8. This is 1 or 9. Is 1 too small? If this is 1 and 7, no, this could be 8 and 6, and it would still be okay, wouldn't it? I think 1, 7, 8, 6 still works. 1786 doesn't work. 1786 is 8 plus 8 plus 6. Oh, that's only 22. Yes, okay. It is not 22, or it's not 26. So that is a 9. Which makes circle 7. Makes X 5 or 9. $23 and $25 in box 1. Adds to odd, but can't be triple odd. Right. Okay, so all of these cells together, I need at least one odd in here. And I need an odd number of odds. But if I put 3 odds in here, that's not going to work. So that means this is an odd and 2 evens. And this is an odd and 2 evens by the same argument. But that's all the evens. And so MicroStudies' point is, therefore, all of these are odd, which is cool. This can only be 1, 7, or 9 now. If only this were a real diagonal for Sudoku, it would be huge. Ah, okay, that's huge. Okay, so Sayori's point is now I need to put a 2 in this row, and it's certainly not going there because this would need to be an 11, which although Josh would prefer if there were 11s in the puzzle, sadly there are not. So there is a 2 here. Uh, but if there's a 2, then this needs to be a 2, 6, 8, 9 cage. Sorry, 2, 6, 8, 9 is the only way that you're going to make a 2 there. But of course, those aren't the 2. So that means this isn't a 9. Oh, that's not the 9 either, for the record. Oh, and it's not a 6 either because of the 2, 6 pair. So actually, that's an 8. Which actually gets rid of the 8 over there, which means that there's an 8 in one of these cells. It's not that one. So there's definitely an 8 in this cage, which only leaves infinity options. But there's no 9 in it because the 9 is over here. So we can say 8 but no 9. And then look at options, and there's still a bunch of options. Yes. I can use this by the secret that I know what the 4 even digits are. So this is a 4. Thank you, Nikolai. This is a 2 or 6 for the record. Ooh, David has gifted 5 memberships. Oh, thank you, David. Sayori, Tristan, AM 1028, Anti-Night, and Jay, congratulations on your new memberships, and thank you so much. Enjoy your emotes. Thank you so much, David. Let me get you a donation dance. Boop 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 boop. Woohoo! Woohoo! Thank you so much, David. Enjoy your emotes, Tristan. Now you can use the cool Zach emotes. Coming soon, a Santa Zach emote, by the way. Belzita has made us a lovely Santa Zach emote, so we are going to have that debuted soon. It was also David earlier, Paul Fly. So thank you so much, David. Greatly appreciated. Yes, David, that was awesome. Thank you so much. Greatly appreciate your support for the stream. By the way, welcome to our new Jay, Jay Grolks. Welcome to the stream. You will be very happy here. We have a whole gaggle of Jays, or whatever the collective noun for Jays is. I'm not quite sure. But welcome, and I hope you enjoy yourself. I'm noticing that in this corner, in this row, I need to have a 1 in one of these 2 cells, and in this column, I need to have a 1 in one of these 2 cells, so that means this is a 1. A confusion of J's. So this is even, and it is a 4 or an 8. There are many suggestions as to the proper collective noun for J's. Let's see. Okay, that was cool. I always enjoy that sort of like this thing has to be here in the row and here in the column, but they're both in the same box, so they have to be in the intersection. I don't know, that is another of the like deductions that always delight Zeta. Let's see. There's a thing about the 21 cage in box 9. Yes. Sorry. Carl and Nicholas have done math on what a 21 cage is if it has 3 evens and a 7 in it, which is that it's 2, 4, 8. So therefore, this is a 6, which makes that an 8, which makes that a 4, which makes that an 8. Which means that's not a 4. 4 in row 3. Oh, this is row 3. Do I know for sure this isn't a 4? Yes, I do. Wow. Yeah, because this 4 corner mark C's up there is Screaming Ice Cube's point. This is a great spot that I never ever would have made. This 4 corner mark C's there. That actual 4 C's there, and so therefore that's a 4. Also, now this has to be even because there's too many odds in the row for it to be otherwise. So this is even, even. So this is odd, odd. And we know that these sum to 14, as do these. So we've got that. And so these are 3, 7. And so that is the 7 and the 3. So that is a 1. The 6, 8 pair places the 6 over here. I buy that. Thank you, Sayori. This is a 5 or a 9, I suppose. Row 3 needs a 3, and it goes there. I like that. Thank you, Martin. Oh, we have all of our evens in row 2 now, so therefore that's odd, and therefore that's odd by the parity mirror that I've apparently forgotten because when I placed the 6, I didn't mirror it, but actually now this box is just done. So the corner marked 8 doesn't go over there, so it goes up there. Also, this 2 or 9 is blue, so it's actually a 2, and that's actually a 9. And that's actually, oh, these are a 5, 7 pair, which makes that a 9 and a 5 for what it's worth. Makes that a 9. These are also a 5, 7 pair, apparently. This is a 4. Nicholas points out. So that's a 2 and a 6, and that's a 4. These are a 6, 8 pair. No. These are a 2, 8 pair. Second time's the charm. Oh, also, this is a 9 by math. I would believe that. This is only a 3 because it's an odd number that's not 5, 1, 7, or 9. So that's a 3, which means my remaining odd digit in the box is a 5, and it goes there. And my remaining even digit in the box goes there. And it's a 2 or a 6. Sorry, 2 or 6. Oh, and I should reflect. Oops, that's not what I wanted to do. Not what I wanted to do at all, Mark. That was a disaster. You can come back later, though. We'll be ready for you in a minute. We can reflect these 2 down to here, and reflect these 2 down to here, and get our last of those sorts of things sorted out. Row 5, column 6 needs math professoring, I am told. So these sum to 24, so that's a 2. So that is no longer able to be a 2. In fact, this just is an 8. These are a 2, 4 pair. These aren't 2. This has become an 8. This has become a 2 or 6. So one of these is a 4 for what it's worth. Let's see. So the only even left in this row is a 4. The only even left in this row is a 6. That sells a naked not even. And there's an odd number of odds on the diagonal. So we get that. So that is now a 6, and that's a 4. That's an 8. This is a 2 or a 4 for what it's worth. But if this is a 2 or a 4, that's a 2, 4 pair, which looks over there and makes that a 6 for sure, which gives me the 2 and the 6. That makes these a 2, 4 pair. So if there's definitely a 2 and definitely a 4, I guess there's still optionality, annoyingly. Oh, is Sarah back from the birthday dinner? Oh, yeah. Sarah did make it back for them. Happy birthday, Sarah. Everyone wish Sarah a happy birthday. I hope Sarah had a good birthday dinner. Oh, I'm being told I can finish the coloring. That would probably help. So that diagonal reflects down here, I believe. I'm being ambitious and attempting to reflect with my intuition. One of these is a 2. Oh, one of these is a 2. which means that has been a 4 since even before I did this. But that's the one that's the 2. That's the one that's the 1. That's a 6. So that's a 3 by math. So this is a 5 or a 9 as well. So the 1 in this row goes in one of these two cells, and the one in this column goes in one of these two. So we get the crisscross zeta delight again, as we call it around here. So 9, 5, 3. So we get all of this stuff over here, which has apparently made this a 7 and a 1. Those a 3, 5, 9. Let's see. Can do all of this. So that is a 5. Oh, there's math to be done on this cage. That is helpful. So yeah, so these currently sum to 18, so that needs to be a 5, or the cage math doesn't work. 3, 5, 9, 9, deet doot deet doot. Why do I feel like that was probably MicroStudy's fault? 7, 5, 1, 7, 7, 1. Wow, and that just did everything. So now our bet tree is a 1. Josh was so close. Josh was just 0 away, which you'd think would mean that Josh would win the bet, but sadly I don't think it works that way. Lovely puzzle, Mr. Menace. I quite enjoyed that. It took a bit to figure out how to break into it, but then a lot of the pencil marks we made while sort of figuring out how to break into it were useful in the solve. Fortunately, Josh was spared, apparently, because Tristan forgot to start the betting. Yes, only missed by a single order of magnitude. That is... I remember some students a while ago saying that they couldn't believe how many points the professor took off because they'd gotten it right except for the power of 10. It was like they had gotten like a 23 in an exponent that was supposed to be a 3. It's like, well, in some sense your answer is very close, and in other senses your answer is off by a factor of 10 to the 20th. But yes, the disguised bet tree over here. Alrighty, well, that's about a good place to wrap up stream for today. Thank you so much to David for all of the gift subs. I hope all of you with new gift subs enjoy it and enjoy your Zach emotes. And if you're not able to subscribe, you can hang out and hope that you get a gift sub at some point in the future. There's a few people who give them out, and it is always greatly appreciated when they do so. So thank you. If you want your Zach emotes right now, you can do that by supporting the stream financially, which you can do by clicking the join button down below, where you can do it for as little as $5 a month. Greatly appreciated to all of you who do. Thank you so much to everyone for all of your support. It really means a lot and helps us keep doing this. Special thanks also to the turbines out there, the people who donate at the top level: David, Nordy, Franco, Daniel, Danita, Nell. Did I say Nordy? Why do I feel like I didn't say Nordy? I should have said Nordy. But anyway, Nordy, and thank you for the puzzle today, Nordy. That was also quite enjoyable. We did this sort of build your own Nordy skyscraper earlier, if you missed it. Thank you so much to everyone. I will see everyone around very soon. I'm streaming next on Sunday, and then on Thursday, and then on Friday. I'll let you know exactly what time the Thursday stream is eventually on the Discord. But thank you so much for watching. I look forward to seeing everyone again real soon. Bye for now.